Welcome to the study of dynamics of motion. In the previous episodes, we learned about the relationship between force and motion, the parameters of motion, and Newton's first and second law of motion. In this episode, we will examine the action and reaction of forces as embodied in Newton's third law of motion. The law states that to every action there is always an equal and opposite reaction. Till now, we have been examining the concept of force and motion in the context of a single object. Often, we come across situations where objects come in contact with one another with a considerable force within a fraction of a second, resulting into a collision. Such kind of a contact is referred to as impact.
Impacts are commonplace. A shot put creates an impact when it hits the ground. There is an impact when a ball is struck by a batsman. Likewise, the cue ball creates an impact when it collides with other balls. These kinds of impacts result from impulsive forces, which are implicit in Newton's second law of motion. An impulsive force can be defined as the force that acts for a time that is short compared to the time of the event. As the impulsive force acts for a very short time, it cannot be measured directly. Therefore, it is measured by determining the change in momentum. The game of billiards is a good example to understand the principle of impulsive force. Here, the cue ball hits the target ball with a certain amount of force, say F. At the contact point, the force gets transferred from the cue ball to the target ball within a small period of time, say delta t. This transfer of force creates a change in the momentum of the target ball, which can be measured as delta p. As per Newton's second law of motion, the change in momentum, delta p, is the product of force F and time of contact, delta t. Therefore, the change in momentum, that is, delta p equals F into delta t, is the impulsive force. If the contact time is increased, the effect of impact will decrease considerably. This can be observed in the game of cricket. When a fielder stretches his palms in the path of the ball, he is likely to suffer an injury as a large force of the ball gets transferred to his palms in a very short contact time. But if he prolongs the time of contact by drawing his palms along the path of the ball, the impact will be less and he will not drop the catch. The consequences of some impact will be quite devastating. Our Earth has witnessed several instances of impacts in its history. One such impact is that of the meteor that struck at Arizona in the US some 50,000 years ago, creating a gigantic crater which was 570 feet deep and 14,000 feet in diameter. In the game of billiards too, the phenomenon of impact can be witnessed when the cue ball strikes the target ball in a very short period. As the cue ball impacts, its entire momentum is transferred to the target ball, making it move in the direction of the force applied by the cue ball. At other instances, a different phenomenon can be observed. Upon contact, the cue ball and the target ball move in opposite directions. Such reactions can be noticed in several situations. The force of the cue ball is the active force, and the force of the target ball is the reactive force. The active force of the cue ball makes the target ball move in one direction, while the reactive force of the target ball acting on the cue ball makes it move in the opposite direction.
Such instances of objects contacting each other and moving in opposite directions are at the center of Newton's third law of motion. The law states that for every action there is an equal and opposite reaction. A large number of devices work on the principle of the third law of motion.
In rotating sprinklers, there is no mechanical device to rotate the nozzles. Instead, it is the action and reaction of forces that make the sprinkler rotate. While the active force makes water jet out of the nozzles, the reactive force of the water jet pushes the nozzles in the opposite direction, making the sprinkler rotate. Not just simple sprinklers, but rockets too work on the principle of action and reaction. The active force of the burnt fuel escaping from the rocket vent creates an equal and opposite reactive force to provide the thrust needed to propel the rocket on its path.
The three laws of motion which we have dealt so far can be studied in the mechanical system of spring balance used to determine the weight of objects.
When not in use, the pointer rests at 0. It continues to rest at that point until it is made to change that position by the application of an external force, such as a 1 kilogram weight. The external force of the weight makes the pointer move in the direction of the force applied. This movement is as per Newton's first law of motion, which states that a body continues to be in a state of rest or in a state of uniform motion in a straight line unless it is compelled to change that state by external forces. Thus, Newton's first law gives the definition of force. In the spring balance, the principle of the second law of motion can also be observed. The force required to move the pointer downwards is generated by the force of gravity acting on the mass of 1 kilogram. As a result of the gravity force, the pointer moves downwards with a changing velocity, leading to change in momentum of the pointer. The momentum so produced in the pointer is proportional to the gravity force of 1 kilogram force acting on it. This is all about the second law of motion, which states that the rate of change of momentum of bodies is proportional to the applied force and takes place in the direction in which the force acts.
The principle of the third law of motion can also be observed in the spring balance. When the weight is suspended, the pointer moves up and down the scale before coming to rest. The downward swing is due to the active force of the weight, and the upward swing is due to reactive force of the spring caused by the weight. When the active and reactive forces get balanced, the pointer comes to rest.
This in fact is what the third law of motion states, that for every action there is always an equal and opposite reaction.
Each of the three laws is set to serve one objective. The first law defines force as an external agency that changes or tends to change the state of rest or of uniform motion of a body in a straight line. The second law provides for the measurement of force in terms of the rate of change of momentum, which is a vector quantity. The third law specifies the action and reaction properties which are inherent in all forces whenever they come into play. In addition, the third law, in combination with the second law, indicates the principle of the conservation of momentum.
Momentum always gets conserved. For instance, when the bullet is not fired, the momentum of the gun, PG, and the bullet, PB, is 0. PG plus PB equals 0. When the bullet gets fired, according to the third law of Newton, the gun exerts a force on the bullet, Fg. And the bullet in turn exerts a force minus Fb of the same magnitude on the gun, but in an opposite direction. These forces obviously act for the same small length of time, delta t. By Newton's second law, the momentum acquired by the bullet and gun are Pb equals Fb into delta t. Pg equals minus Fg into delta t. Since the action and reaction are simultaneous in a very short time, delta t gets cancelled. Therefore, the momentum acquired by the bullet is equal to the product of the mass and velocity of the bullet. Pb equals mb into vb, where mb is the mass of the bullet and vb the velocity of the bullet. And the momentum acquired by the gun minus pg is equal to mg into minus vg, where pg is the momentum acquired by the gun, mg is the mass of the gun, and minus vg is the velocity of the gun. The total momentum when the bullet gets fired is mb into vb plus mg into vg, which is equal to 0.
This implies that the total momentum before and after the firing remains constant at 0. This kind of action and reaction, where the momentum of the bodies in a system get conserved, has yielded the law of conservation of momentum. The law of conservation of momentum states that when two or more bodies interact with one another, their total momentum remains constant, provided no external forces are acting.
This can be clearly illustrated with the game of caroms. When the striker hits the formation of coins, the momentum of the striker gets completely transferred to the coins, resulting in their motion. Thus, the total momentum before and after the strike gets conserved and remains constant, provided no external forces act on it.
The principle of conservation of momentum, like the three laws of motion, is in action everywhere. Examine such situations and explain how the laws are operating in them. This will enhance your understanding of the Newton's law of motion.
Besides your own textbooks, read the books suggested here. Principles of Physics by N. Subramanian and Brijlal, published by S. Chand & Co. Limited, New Delhi, 1990. Physics textbook by Arvind Kumar, B.K. Sharma, P.C. Jain and others, published by the National Council of Educational Research and Training, New Delhi, 2002. Pradeep's Fundamental Physics by K.L. Gomba and K.L. Gogia, published by Pradeep Publications, Jalandhar, 2003. Engineering Mechanics by S. Timoshenko and D.H. Young, published by McGraw-Hill, New Delhi, 1956. The questions for you to answer are: define impulsive force and impact. Describe various situations of impact in real life. Define the third law of motion. Describe active and reactive forces with suitable examples. Define the law of conservation of momentum and explain how Newton's second and third law coexist to conserve momentum. If you have any doubts to clarify, or if you wish to watch the unit again, write to the Director, Consortium for Educational Communication, NSC Campus, Aruna Asaf Ali Marg, New Delhi, 110067, or email us at cec@del12.ac.in. vsnl.net.in. You can also write to the Director, Educational Multimedia Research Center, University PO 673635. Email ID is emmrccalicut@yahoo.co.in.
Hello and welcome to a session on multi-camera prediction. Most of the time when we think of video prediction, we focus of shooting with one camera. The very thought of trying to control multiple cameras can cause some people to break out in hives. However, it is not as hard or complicated as it sounds. It is also quite useful. By setting up multiple cameras to record events such as sporting events and debates, the videographer can create a completed project right there on the spot, ready to duplicate or broadcast. No more post-production delays, since we are actually editing as we shoot. Every day we watch multi-camera predictions without even thinking about it. The evening news, talk shows, sitcoms, sporting events and rock concerts are all shot with multiple cameras that are connected to a video mixer and mixed onto a single tape and sent to your television via cable or the airwaves. At a sporting event like a major league football game, the program director or producer may have dozens of camera shots from which to choose. The prediction team considers every possible angle so they can capture every moment. With multiple cameras, there is less of a chance to miss any action. One can also walk away after the prediction knowing that their prediction is in the can and a good product is ready for its audience. Whether it's a sporting event, a graduation ceremony, a school play, a concert or a parade, with 2 or more cameras, you can create a finished product that will amaze your viewers. These live-to-tape predictions will add a sense of really being at the event and add to the strength of the memories they create. In this session, we'll look at the technical requirements of a multi-camera shoot as well as the aesthetic and prediction aspects that we need to take into account. We'll also explore the roles of the various crew members and the communication between director, cast and crew while engaging a multi-camera prediction. Multi-cam shooting. While the thought of setting up a multi-cam shoot can be daunting to producers or directors who have never done it before, knowing how to do it right has some massive benefits. Not only do multi-cam setups help keep time on set to a minimum, but they can also provide creative freedoms that aren't otherwise offered by single camera environments. For instance, if you are directing a comedy and want to allow your actors to improvise, a multi-cam setup would be ideal so that you can catch all of the spontaneity while also having enough coverage to cut together the scene cohesively in post. What is multi-camera setup? A multi-camera setup or prediction is where you are filming on location or in a studio with more than one camera to capture everything going on in the moment, either streaming live or pre-recorded and sometimes in front of studio audience. It takes a lot of people to make this work with all kinds of jobs, some on stage, some backstage, some on the sidelines, but it takes a lot of organization and talent to make it work. Whether you are interested in shooting multicam as a means to keep your budget down, to give your actors more freedom, or you simply have no other choice, you will go over a few considerations for getting started with multicam shooting. Camera setup. Multi-camera productions use more than one camera to capture each shot and scene from different angles. This means the directors and producers have more freedom and choice in the shots used, which comes in very handy for creating a linear storyline. Consider a production with 3 cameras. Generally, 2 outer cameras shoot close-up shots or crosses of the 2 most active characters on the set at any given time, while the central camera or cameras shoot a wider master shot to capture the overall action and establish the geography of the environment. In this way, multiple shots are obtained in a single take without having to start and stop the action. Advantages of multicam production. Multi-camera production is a method of filming. 2 or more cameras are set up either in a studio or at a location and film simultaneously. The cameras will be set out to film a scene from multiple angles to gain a variety of shots. This is different to single camera production, which uses only one camera and scenes are repeated to get the required shots from different angles. Getting all the shots in the moment. There are many different opportunities and limitations when working with multi-camera. The most obvious plus side is getting all the action live as it's happening. For instance, in a football game, it would be much harder to see and understand what's going on if they filmed it with just one camera with a wide angle lens. You wouldn't be able to get close-ups easily. You would need a master shot of the game to cut back out, to which it can really be done with the use of many cameras. Obviously, it varies from game to game depending on the size of the stadium. Time saving. If you are shooting a sitcom and you have lots of different shoots and many locations, having to wait to send one camera to all those places would take a long time. With multiple cameras, you can film 5 locations in one day as opposed to one, thus saving so much time. Enhanced emotion or reactions. When shooting a scene with 2 actors or people, when live arguments can ensue, which could cause for a heated debate, which is real and tense and dramatic, therefore entertaining, and when using actors when they are actually playing the whole scene out, not just one at a time staring at a wall, you might get a better performance out of them. Lighting and sound is a lot easier to control as the cameras will remain stationary there, for sound and lighting do not need to be adjusted. The filming process is quicker when compared to single camera productions, as no scene has to be done multiple times. This is important for soaps as they are produced on a regular basis. Post-production is not normally required as cuts are done live. If it is needed, it does not normally take a long time. Scenes only need to be shot once, as there are multiple cameras filming from all required angles. The multi-camera setup allows for live broadcasting. All cameras are filming at once, so cuts can be made live to show a scene from the best angle. There will be no continuity issues as cuts between shots are done live. Multi-camera productions get the best reactions from actors, comedians, athletes, etc., as no scene needs to be repeated. The reactions will therefore be genuine. There is more coverage of everything as cameras are recording from different angles using different frame sizes. Now, disadvantages of multi-camera prediction. Expensive. Obviously, the main reason multi-camera may not be so popular because it's so expensive. Getting all the equipment, booking studio, the crew and operators are all a part of it. Takes longer to set up. When filming in a studio, you have to get the lighting right for all angles and check the sound to make sure it's right, and setting up all the cameras and the scenery and props can take a long time. It takes a long time to set up for a recording of a multi-camera prediction, as lighting, camera angles, audio levels and the set design all have to be set up for one shoot. Filming location options are very limited with multi-camera prediction. Predictions are filmed on sets or in studios such as sitcoms, chat shows, soaps and game shows, or on location for live broadcast such as concerts or sports events including football matches or the Olympics. This differs from the single camera method, as one prediction can include footage from a variety of locations. Minimal lighting control. Lighting has to be set up for every person in the scene as well as the foreground or background all at once. Flexibility with equipment. You have to be careful not to get other cameras or lights in shot. So the studio floor plan has to be well thought out for each camera position and angle. Roles in multi-camera prediction. There are many different jobs that need to be performed in order for the prediction to run smoothly and work as a whole. When using multi-camera prediction, there are many roles that people would have when in prediction or filming, each of which is vital to making the finalized or live footage look the best. Below is the most common in multi-camera techniques. Camera operators. This is an important job because the whole point of multi-camera is being able to shoot many things at the same time from many different angles. For example, when filming a chat show, the camera operator's main job is to follow instructions and do exactly what they are told through their headpiece by the director. They must understand the basics of camera angles and positioning, etc., to be able to get the right shot being asked for, like if asked for a medium shot or close-up of guest. They have to be quick on the zoom and focus and get to the shot as and when it's needed. Sound mixer. A sound mixer's job is to make sure the sound coming from the studio is absolutely clear and loud enough to be heard without any difficulty. They have to adjust the volume of microphones attached to the guest by performing sound checks before a live show, making sure all batteries are charged and everything is on and working correctly. Vision mixer. This is the most uniquely designed role noticeable in multi-camera prediction compared to other roles. The person who is the vision mixer, creative insight, is the one who tells the mixer what shots to go to, video transitions, etc. Their main job is to switch from one camera to another, mostly using cuts but also fading when appropriate, also transitioning from VT, that is videotape, footage back to the live feed and out again. Set designer or coordinator. They decide what goes where and collaborate with the director to decide how many seats needed for guests and where best to position them. Also the lighting and how it looks best and casts the least shadows without blinding the presenter and guests. Also making the background appropriate for the type of show and aesthetically pleasing for the viewer. Director. This role is one of the hardest and the most multitasking roles in multi-camera prediction. This person acts as a center point of the team who basically is in charge of everything. He or she tells everyone how to perform and what to do throughout the performance. In pre-production and practicing, the director has the responsibility to let everyone know what to do and how everything is going to be filmed. When doing the actual filming for real, the director will mainly be with the vision mixer, telling him or her on when to cut to different shots, what to add, the pace of editing and more. When he or she is not with the vision mixer, the director will usually either check or ask the floor manager to check on the crew and the rest of the team, whether it would be to see if everything is okay, letting them not to do if something is wrong or a heads up on what type of shot the director wants next. The director is in charge of what we see on the screen. They decide which shots to cut to and when and what kind of shots they are. They decide where to get certain angles and shots that will look good on camera. They can talk directly to the presenter on the set of a live show through an earpiece to tell them anything important they need to know. For instance, if something's taking too long, they can hurry it along. And if they want them to say something specific or do something, they can tell them directly. They also speak to all the camera operators, telling them when to set up a shot and how to frame it. VT operator or videotape operator. The job of the VT operator is to set up prepared VTs in the correct order of how they will be presented on the show and cue them before they need to be shown. They communicate directly with the director, who will tell them when to start playing the VT. Presenters. A presenter needs to adapt their mode of address to fit the situation of the show they are on. For instance, a new show would be highly serious and formal, rarely funny or particularly entertaining like that of a music chat show or celebrity chat show. They have an earpiece so they can hear everything the director says and instructs how to behave. If something went wrong, he can communicate to change the subject or improvise it. They have to go into the live show having read a script and maybe even practiced with the auto cue beforehand and also made sure they know who they will be talking to and what will be discussed, specifically what questions may be asked. They may have all type of question cards to help them with that too. Along with everything else, they need to make sure they are appealing to a certain target audience by what they wear, how they talk and their whole behavior, whatever fits with what type of show it is. Floor manager. The floor manager is always in direct contact with the director. They are the director's representative on the studio floor, showing their job for them through themselves when the director tells them an order through their headset. For instance, cut or quiet on set. They need to communicate that loudly to everyone on set. They also give direction to the rest of the crew and the guests to sort out sound and lighting and seating arrangements to make sure everything goes as planned. They also have to make sure that the studio floor is an appropriate environment with required props and lighting as the director conceived. Formats of multi-camera production. The main genre that multi-camera is used for are public events, concerts, sports, chat shows, game shows, news shows, etc. Multi-camera techniques are employed in the formats above for a variety of reasons. All live events must be filmed using the multi-camera setup, as there is no chance to film a scene from more than one angle. Multi-camera formats such as game shows and soaps have several episodes filmed per day. This is cheaper as crew and equipment is only needed for one day for a few episodes instead of being needed for many days to film a few episodes. This also saves time. For example, with a single camera setup, only one episode of soaps can be filmed in one day. If those are filmed using multiple cameras, each scene only needs to be filmed once when the shoot goes as planned. Filming using more than one camera allows a variety of shots or angles to be achieved. For example, a live football game that is being broadcasted online and or on TV is always filmed with many cameras. This means that cameras can be placed all around the pitch for the best coverage. Cameras are placed in many locations and all have different purposes. Camera placed above the crowd to get a wide coverage of the action. Camera placed behind each goal post to film goals. Camera on the sideline for throw-ins or corners. Camera set up to film individual players or managers, etc. These variety of shots allow instant replays to be shown to the viewer from the best angle. Using many cameras also keeps the viewers interested. If the football match was only filmed with one overhead camera, many viewers would get bored. The visual style of a multi-camera production can be dependent on the format or the production. For example, a sitcom or a music concert, if the music is slow cuts, this will keep the viewer engaged, but overall the visual style is quite calm. This is different in comparison to a sports event such as a football game. The visual style of a football game is quite simple, as each camera has a specific purpose. There will be fast cuts in a fast-paced game, but if there isn't a lot of pauses, the visual style will seem more slow-paced. One camera angle is often shown to the viewer, mounted high up to show a wide shot of the action. This is normally followed by a different shots of individual players. Meaning is communicated to a viewer through a variety of camera angles and movements, and also by showing shots of audience or crowd or other people in frame. For example, during a music concert, slow camera movement may be used, such as slow tracks of a stage or slow zooms of the music artist. This differs from sports events, as sports are usually packed with action. For example, during a football game, camera movements will be fast to follow a player or to follow the ball. Meaning is also communicated to the viewer by showing the audience reaction. Let us summarize what we have discussed so far. Here we discuss in detail about the importance of multi-camera shoot over single camera productions, the technical requirements of a multi-camera shoot, as well as the aesthetic and production aspects that we need to take into account. We will also explore the roles of the various crew members and the communication between director, cast and crew while engaging a multi-camera production. The advantages and disadvantages of multi-cam production along with the various formats of multi-camera productions are also discussed. Now you can try to answer the questions given here. What is the role of videotape operator in a multi-camera production? Differentiate single camera and multi-camera production. What is the role of a sound mixer? Mention some of the genres of program using multi-camera. Is multi-cam production more expensive than single camera production? Hope that you may go through the references for further reading. Television Production, 14th edition, authored by Owens, J.M., published by Focal Press, Elsevier 2009. Independent Producers Guide to Film and Television Contracts, authored by Philip Alberstadt, published by Focal Press, Boston in 1999. Video Field Prediction and Editing, 6th edition, Ronald J. Compassi, published by Allen and Bacon, Boston in 2003. Hope that this session was useful to you. We can meet again with another topic. Have a great time.
Welcome to the interface. Today in interface we have our honorable guest Dr. Capote Noy. Dr. Capote Noy is Deputy Division Head, Nuclear Data Section, International Atomic Energy Agency, Vienna. Being the representative of IAEA and the Deputy Division Head of Nuclear Data Section, can you elaborate what are the activities of Nuclear Data Section?
Well, first of all, I would like to appreciate the invitation to come to the University of Calicut on behalf of the IEA and of my own name. It's a pleasure to be here to teach the students of the university about the activities of the IEA, in particular the activities of the Nuclear Data Section. So we have been, the main goals of the activities of the Nuclear Data Sections are 3 points. We are working on data dissemination. This is through the maintenance of the web page. We are also coordinating international projects with member states, so with experts from all member states in order to produce data. And then finally, we are contributing also through our own technical work of our staff to make the data producing those projects better. So I think this is a good summary of our activities.
So what is this nuclear reaction course means?
Well, of course, this is part of the production of nuclear data. We need to use we have experimental data on one side, and experimental data clearly you have installation, but then on the other side you have modeling, and for modeling this is where you play the role the nuclear reaction codes. And in particular, what we have been doing during the workshop organized at the university is to try to teach students how to use those nuclear reaction codes.
And what are the various types of nuclear reaction codes available from the nuclear data section?
I mean, at the nuclear data section, we have focused on nuclear reaction code system Empire, which is freely available. It's an open source code. And this is the main task. We all, of course, have collaboration with other data centers and with other people who produce his own codes. So we try to disseminate and distribute Empire as an example of what the nuclear reaction code can be, but it's not the only exclusive. It's not the code. There are many other possible ways of doing things. And I think what is important is that people learn how to access the data, how to get the right data, how to compare experimental data with calculations. So this is the main goal of the nuclear reaction codes.
And what are the various types of other nuclear reaction codes apart from this Empire?
Right now there are many reaction codes let's say, in the market available for different applications. The advantage of both, I will say that probably one of the most known apart of Empire is Talis code from Dr. Arjan Koning and Dimitri Hochman and collaborators. And is similar capabilities I think that it's good to have some different codes, so you can compare results from different codes. But the important thing, these are very complex systems, so you can imagine that the development of such reaction model reaction code system takes more than 10 years. So in any case, when we are talking about the system, it's because it's really not one single code. It's the whole capabilities, including plotting, graphical user interface, comparison with experimental data. And this is, I think, what is the important point to stress. It's not something that you really sit down and do one simple programming. It's a whole environment and complex system.
Actually, a nuclear reaction code is supposed to explain the nuclear reaction model, in which the real physics will be explained. Then basically the physics will be unique thing. Then why do there is different types of codes?
Well, there are different type of codes because even if the physics is the same, there are different ways of implementing the physics. So, of course, the way that on one side you have the physics, at the end of the day, I think the most important thing is the word model. That's the key word. Model is an approximation to the physical reality. But actually, there is not unique way of approximating the physical reality. So you may have as many models as people are working on a given problem. And in a way, the fact that we have different models is reflected in the fact that we have different reaction codes. That's, I think, is the best way of saying why you have, what you expect to have difference between them.
So, can this Emmrc code can unify the various concepts of nuclear physics behind this? How far it will be helpful?
We try to be comprehensive for a particular given problem. I will say that what we are doing, we are trying to calculate, to use reaction models that are applicable to produce nuclear data for fast incident particles. And that means this data could be useful for many different applications. That mentioned some of them is just energy applications, nuclear reactors, but the data are also very useful for other applications, what we call non-energy applications, that range from astrophysics to things like medical applications. How you can calculate what is the possible yield of the medical radioisotope using a nuclear reactions. And this broad definition means that the code could be used for many different things. And this is valid not only for Emmrc, it is valid for any other of the other reaction codes.
So, nuclear reaction code Emmrc is an open source code you are mentioning. So, what do you mean by open source code?
Well, this is quite, I think open source codes started with Linux, and the idea is simple. The idea is that everybody can contribute. And actually, one of the key points that we try to come to the member states countries of the IEA and to teach students how to use the code and to teach staff is that the fact that if they are interested in applying the code for any particular problem, they are open to contact us, they are open to make a proposal, to do some coding, and we can integrate later. And the source code is available. So at the end of the day, this is something that is for the benefit of all member states of the IEA. And this is quite important concept, because it's not the problem when somebody is developing a code and you are limited to one particular place, to one particular lab, to one particular country. We really, by definition, the IEA, whatever we produce is available for everybody. And this is quite important to keep the concept of open source code, so everybody can contribute. And it's really, from the very beginning, the code has been an international collaboration, and this is the way that we want to keep it.
So, in this case, what are the types of collaboration or contribution do you expect from students and young scholars?
Well, actually, this is a good question. It depends on what they are doing. Ideally, let's say if there are people working in some specific physics where the code could be applicable for a nuclear reaction, let's say you are doing heavy ions, then maybe Emmrc is not especially good for heavy ions because there have not been people specializing in heavy ions collaborating with us. This is an opportunity for students to make a contribution to the whole system. But they are getting a lot from what is already available, but they can also contribute, and their contribution is quite important. So we are looking forward meeting people who can contribute to the code and who can use the code also in their own work. Because at the end of the day, the first the first reason why we developed the system was to use in our own work and to try to stimulate people using it through the open source mechanism to make more wider spread of the calculated data and the reactions that is there.
Can you explain what are the contributions from Indian side towards this nuclear reaction code in general and nuclear reaction theory, and particularly this nuclear reaction code Emmrc?
Well, I think in India it has been a long tradition of nuclear physics. So, for example, they have been scientists here contributing to the project on not only on the nuclear physics side, but also to the input data we have been using in the project. And India was one of the collaborating partners of the Ripple project. So I think this is important, and we are really looking forward that collaboration continues. So right now I think that in India, this is one of the countries where is more widespread the use of Emmrc. And this has a direct impact of the fact that we have been coming here, we have been trying to train people, and I do see, I mean, I have been coming to India already for 6 years now, and I do see the real impact. There are some people who are getting much better, they are getting trained, and this is just a chain reaction. So you first start getting 2 people, those 2 people train 4 people, and then at some point you really have a whole community using it. And this is for everybody's benefit. So I think that the contribution of any given country, and India is not an exception, is quite important in this task.
So can you briefly explain what are the importance of this nuclear reaction data in nuclear safety, which is a matter of concern for public?
Well, nuclear data underlies everything. So is not only safety is one of the aspects, but nuclear data is important when you are going to the hospital and you are doing radiotherapy. Nuclear data are important when you have a nuclear power plant, and is quite important for the operation of the power plant. It's quite important for the safety, because indeed, for example, you need to know how long you can operate the nuclear power plant, and at the end of the day, that depends on the underlying data you have. That determines, among other things, the safety of your reactor vessel, how long you can operate the plant. But this is one part. There are many other things for the safety of the plants, and the IEA has a special department dealing with nuclear safety. So there are many other regulations. But of course, we are doing our small part to make sure that at least the data that is being used in any applications, and nuclear energy is just one of them, is also important in medical applications, in other applications. This should be the highest quality data. And if you are using the highest quality data, you are setting the first stone for the whole building of nuclear applications. And that's, I think, the important goal.
Can you briefly explain what the procedure for getting the required nuclear data from the NDS site?
Well, we have a website which is accessible from the whole world, but in particular, India is one of the member states where there is what we call a mirror site. A mirror site is just reflection, literally, is a copy of our website in Vienna at the IEA here locally. And that's really greatly improved the access of the local people to this data, because you don't have to connect to Vienna. You have exactly the same data available locally. So that's improved the availability. But in general, our website contains all the information about all the projects, and our section just happened to have the anniversary, the 50th anniversary. So the section started the work 50 years back. We can say that in our website you have data for the last 50 or 60 years of nuclear physics. And it contains the most comprehensive source of information on nuclear data that includes experimental data, evaluated data, and all related data that you may need for different applications.
Can you explain what is the experimental data and what is the evaluated data?
Yes, this is an important distinction, because people, when experimental data is clear, when you do experiments, that's what we call experimental data. So it's a direct result of doing some experiments to measure something. But it's also obvious that, unfortunately, we don't have neither the possibilities, sometimes physical, because you don't have the technical capabilities to measure something. Sometimes you don't have the targets. Sometimes there are other problems. Sometimes you even don't have the resources to make the measurements. They could be expensive. So there is a real need to complement the measured data with something else. And that something else is that you use the models, and then when you combine models with data, this is the point when you produce something that we call evaluated data. And evaluated data, in the nutshell, is the best possible data available for any given application that considers the status of the current knowledge. And current knowledge means both models and experiments.
What are the procedures of evaluation process?
Well, the best definition is that combination of experiments with model data. There could be some cases where the experimental data are really comprehensive, and therefore you may not need models. But very often experimental data are not comprehensive. They don't cover all energies, they don't cover all isotopes, and in that case you really need to combine models that they are not that precise. Experiments are much more precise, but the models always provide comprehensive information. And therefore, the best combination of them, properly weighted, this is when you produce evaluated data.
So, what are various types of standards you are implementing in nuclear reaction measurements?
Yeah, this is an important normative function of the data we are producing. So, it's the fact that on one side, standards is considered to be the highest reference data that can be used in order to make measurements. And I have to say here that when you are measuring something, very often what you do is that you do relative measurements. Relative means relative to something. So you know you have a ruler, and when you are using a ruler, somebody calibrated that ruler. So you don't care about what is the absolute calibration. You really use the ruler to measure some distance. But this is a relative measurement. You are relying on somebody else who produced that ruler. Well, in nuclear reactions it's the same. Somebody measured the cross-sections, and if there is a high-quality work, you may combine many of those high-quality measurements, and you produce what is called a standard. And then these standards can be used in relative measurements. So in any lab, anywhere in the world, they are doing this relative measure of cross-sections. They use the standards they are produced at the IEA. And of course, the standards are produced through international collaboration. We are just coordinating the efforts of producing, in particular, a standard for neutron-induced reactions. This is one part of the work. Additionally, we may mention also that there are what we call monitor reactions, and this is important for charged particle-induced reactions. This is very much used for production of medical isotopes. So in this case, you are using accelerators, and if you are using accelerators, then you need again reference reactions. These reference reactions that are the best known cross-sections, this is what we call monitor reactions. And there are several of them, and this combination, if you are using those data, this is our best knowledge from the experimental point of view for those reactions. But it's quite important to make sure that you keep unique reference to those data or to those standards, because they are used everywhere in the world. You want people to use the same numbers. Otherwise, if you keep changing the numbers, then they are not anymore standards. So I think this is one of the functions that is quite important to have centralized internationally at the IEA nuclear data section.
And when you are using modeling, so there should be various parameters. So what are the typical parameters that one has to use for preparing a code or nuclear modeling? Well,
parameters, of course, is quite important to get a good agreement with data and for the use of the nuclear reaction model to a proper selection of what are the model parameters. It was an, probably the longest running international project of the IEA nuclear data section was the recommended input parameter library, so-called RIPPLE. RIPPLE is precisely the library or the database that contains all input parameters that you need for model calculations. So this is the best recommended set of input parameters. And this project was running for more than 15 years. So it finished in 2009. All the data for input parameters are available in our website, But additionally, this data has been used as input for the reaction codes. In particular, both Emmrc and Thales reaction codes, they fully include the input data provided by the Ripple project.
What are the input data, like you say optical model or level density parameter, etc., etc.?
Well, this is everything is included into Ripple. So Ripple contains 6 big segments, and those segments goes from experimental masses. Then you get resonance information that you need in order to define your level densities. Then you get the level densities. You get the optical model. You get the gamma ray strength function. So essentially you get all really the parameters that you need in order to make a reaction calculation, either for nucleons or for heavier incident particles, and in the typical energy range that goes from a few keV to hundreds of MeV.
So in optical model parameters, what are the information that you are providing? What do you mean by this?
I think that what is important in the optical model is that you are really comprehensive. So there have been so many optical models published in the literature, and let's say 20 years ago, if you were asked, somebody give you a paper and tells you, well, this is my optical model, is written in the paper, and then 2 persons try to use the same paper to reproduce what was written there, and they came up with different numbers. So I think the standardization of the input parameters and the standardization of the codes used for the optical model is quite important in order to reproduce the same cross-section and to have the quality agreement about the calculated data. So that's an important part of having on one side input parameters in a database like Ripple, and on the other side the capabilities to have system codes like Emmrc or Thales that can use those parameters to make to calculate cross sections.
So this Emmrc code uses a unique optical model parameter, or various options are available for covering the wide range of energy and wide range of masses?
No, in Emmrc you can use any optical model which is compiled in Ripple. So actually there are many different optical models, and of course, you may see some of the models which what we call their global models. They can be applied for a wide range of energies and isotopes, but there are also some local, what we call local optical models, and this is probably the best fitted optical model parameter for a given nucleus. So the short answer to your question, it depends on the application. You have many different optical models, but depending on the type of data, the type of calculation you want to do, and the type of application you want to compare to, then you have to select, you should try to do the best selection of the optical model. There are some default selection in Emmrc about the optical model, in order that if you don't do anything, you are going to get some default values. But by no means those default values are optimum for any given case. But they work globally. So this is a difference that you should understand. You don't expect to get with default values the best possible calculation for any given case. But on the other side, the value is that you can get calculation for all the cases that you analyze. And then you study the difference between them.
What are the basic theoretical concepts that is involved in Emmrc code? Basic nuclear reaction theories, what are the associated theories?
Emmrc code, of course, is historically, it started actually from people doing some calculation for neutron-induced reactions. I think the experience that there is in Emmrc code for neutron-induced reactions is very large. Then it's becoming more and more important to deal properly with charged particle-induced reactions, in particular for things like medical applications, ion beam analysis, and other things. So we try to improve our capabilities to reproduce charged particle data. And we have some capabilities also to deal with heavy ion reactions, but they are quite limited at the time. But we see that is important, precisely the collaboration, because the developer team, well, we are always very busy people. So any help, and especially students who wants to engage into the project and to contribute to it, that's really welcome.
So this nuclear medicine as well as radiation therapy, are some of the activities used for medical science. So how far this nuclear data is important in nuclear medicine and radiation therapy?
Yeah, well, nuclear data, they are really, I think, critical in many aspects of medical applications, and that includes things that goes from, when we think of nuclear data, there are not only reaction data, we have reaction data, we have decay data. So decay data includes things like half-life, and half-life is the physical quantity which is critical when you are talking about the medical application of radioisotopes. Because let's say you usually try to get isotopes that has short half-life to treat patients, because otherwise the patient goes away from the hospital and is still radioactive. So you don't want that type of thing. And all these safety aspects, or even how much radiation the patient get from a given isotope, depends on nuclear data, both on decay or on reaction data. So obviously nuclear data are quite important. Then additionally is becoming more and more important. Traditionally people in radiotherapy, they have been dealing with electrons and photons to treat patients. These days in most advanced centers, they are trying also heavy ion therapy. They are using carbon beams, and there the role of nuclear data again is more important, because directly, or you have proton beams. So directly we are talking about using proton beams, which are nuclear reactions, to treat patients. And therefore we do see that the role of nuclear data even in radiotherapy is growing. But even is more important if you want to predict what are the properties, how you can produce better radionuclides, because that's really a question that is fully answered by nuclear data. So how we can improve the quantity and quality of the radionuclides that we are producing, that depends somehow on the underlying nuclear data. So by improving the nuclear data, we are also improving the way that we produce radionuclides, and that has a direct implications on the use of those radionuclides in medicine.
So typically in radiotherapy, they use about 15 MeV and higher energies for therapy. So naturally it is expected to produce neutrons.
Yeah, that's correct. Actually, the neutrons are produced by photon-induced reactions. So you have photon-neutron production. This is one of the reasons that very often these days people don't recommend to use high energy photon beams, that you should try to use beams with typically less than 6 MeV photon energy. And that means is precisely to try to limit the amount of neutrons produced in those cases. And the main reason behind is that the biological effect of neutrons is much higher than the biological effect of photons. So you want to avoid having neutrons contaminating or irradiating your patient. But that's a good question. Again, photonuclear cross-section by definition is a nuclear reaction. So if you want to know, for a long time people who were dealing with radiotherapy, they were not considering neutrons because it was not part of the typical interaction mechanism of photon with the matter. So they were worried about the scattering of photons and a scattering of electrons, but they were not considering the neutrons. And it's quite important. We know these days that the dose from the neutrons could be important, and we should try to take care to avoid the neutron production. And again, there you need nuclear data.
So this photon-neutron cross-section is available in our NDS site?
Yeah, definitely. We have actually we are going to start a new project to revisit the status of those cross-sections at the IEA. But we do have evaluated data, and we have a compilation of experimental data available for photon-induced reactions. So the basic data that can be used for those studies is available, and we try to improve the consistency of those data. That's the reason we are going to start a new project.
Oh, nice. So in this aspect, what are the messages that you can convey to our students?
Well, I would like to thank again the university, but I think the most important thing that every student should keep in mind is that there is nothing replacing the hard work. So no matter how much you learn, how much you get trained, at the end of the day, even we are coming here, we can spend 1 week. And I think if you really have to use properly any of these reaction systems, and they are really complex, we have been developing them for many years. Well, you cannot replace that amount of time. You have to spend a significant amount of time, and I think the most important word there is commitment. So you really have to feel the passion for what you are doing. And if you feel the passion, then you can succeed. You can have success in whatever you are doing, and in particular in trying to use the system we have developed.
What is the future of nuclear physics research in India and in general in the world?
Well, we are looking forward. We think that nuclear physics is quite important part of the society as such. So I really hope, and we are looking forward for a bright future for nuclear physics. So it's quite important, and these days you have nuclear data everywhere.
So we have a nice interaction with you, sir, and thankful to you. Thank you, sir.
No, thank you very much for the invitation. It was my pleasure.
Hello and welcome to the session on educational functions of the state and central government. Education can be defined as the knowledge and experience which a person acquires from his infancy, childhood, adolescence, youth, manhood, and ultimately old age through any agency of education such as school, home, society, etc. In a broad sense, education means the process of development from infancy to maturity. Here, we are more concerned about formal education, which is consciously and deliberately planned for the purpose of training a child, which consists of direct schooling or tuition and the above. Since education is vital for the total development of a nation, the Government of India has taken special care to take roles to control the different functions of education. Role of Government of India in education is one of the major educational controversies of today. The nature of educational administration has been undergoing a radical change since independence. The sudden quantitative change and expansion of education in different levels has brought the educational administration face to face with the local community, posing new challenges. The state control and central control over education is much debated upon. There have been opinions that the state should not take control and interfere in the education of its citizens. Even Herbert Spencer had the same opinion and considered that national education should be given by private bodies. In a country like India, with a wide range of diversity in different aspects, the state-center relationship in education is very critical. At the same time, there have always been controversies as to who would do what. The Constitution of India has made certain provisions regarding the responsibilities of the state and the center on matters of education. It is clearly stated in the 7th schedule, list 3 of the Constitution about economic and social planning, which implies that the Government of India has a constitutional responsibility for the economic and social development of the country as a whole. This can further be connected to a well-known sociological principle that economic and social development is intimately connected with education. The Indian Constitution has provisions to ensure that state provides education to all its citizens. Under Article 42 of the Constitution, an amendment was added in 1976. Education in India has been added in the concurrent list, which means that both the state and the central government will perform the educational functions. The Government of India from April 1st, 2010 implemented a law to provide free and compulsory education to all children
in the age group of 6 to 14. This law is coming into force nearly 8 years after the Constitution was amended. Besides, India is signatory to a number of international covenants, that is Geometry Declaration, United Nations Convention on the Rights of the Child or UNCRC, Millennium Development Goals or MDG, Dhaka Declaration and SARC, which is binding on its commitment for making education a reality for children. Constitutional provisions for education relating to the center and state in India. In the 7th schedule, Article 246 of the Indian Constitution, there is division of powers between center and the state. There are 3 lists of power: the union list, the state list and the concurrent list. The union list relates to the power of the central government. The state list relates to the power of the state and the concurrent list relates to the power of both the center and the state. Placing education in the concurrent list means that the central government has the dominating power. It is the center which shall determine the various policies related to education. It is the center which has the power to carry out uniform educational reforms, shall take steps for promoting national integration through education, provide effective leadership to the state, etc. The union list. This list contains 97 subjects where the following entries are related to education. Entry 13 relates to the power of the state to provide educational and cultural relations with foreign countries. Entry 62, this entry states that the institutions such as National Library, the Indian Museum, the Imperial War Museum, the Victoria Memorial, Indian War Memorial or any other such institutions will be financed by the Government of India wholly or in part, and such institutions will be declared by the Parliament by the law to be an institutions of national importance. Entry 63 is a continuation of the previous entry in the Constitution and states that institutions such as the Banaras Hindu University, Aligarh Muslim University and Delhi University will also be declared by Parliament by law to be institutions of national importance. As per entry 64, the institution like IITs and IIMs will also be institutes of national importance according to the Constitution, and such scientific and technical education will be financed by the Government of India wholly or in part. Entry 65 states that the union list under the power of the state government will have agencies and institutions which are related to the following: professional, vocational or technical training, including the training of police officers, the promotion of special studies or research, scientific or technical assistance in the investigation of detection of crime. Entry 66. The entry states that the state government will have the sole responsibility for the coordination and determination of standards in the institutions of higher education or research and scientific and technical institutions. State list. State list consists of 66 entries. Out of the 66, the following is the entry related to education. As per entry 12, all libraries, museums and other similar institutions controlled or financed by the state, ancient and historical monuments and records other than those declared by or under law made by the Parliament to be of the national importance. Concurrent list. It comprises 47 entries. Among them, the following are related to education. Entry 20 says that the issues related to economic and social planning will be the responsibility of both the central and the state. According to entry 25, both the central and state will have to take responsibility of power with respect to education, including technical education, medical education and universities, subject to provision of entries 63, 64, 65 and 66 in the union list. Entry 34 maintains that the issues regarding newspapers, books and printing presses is also a part of the concurrent list where the power relates to central and state. Educational functions of the state government. Before the 42nd amendment of the Constitution of India, education was a state subject. Entry 11 of the list 2 of the 7th schedule of the Constitution lays down that education including universities subject to the provision of entries 63, 64, 65 and 66 of list 1 and entry 25 of list 3 should be a state subject. The important responsibilities of the state with respect to education are the following. The first responsibility of the state is to provide elementary education to all citizens. Providing elementary education is essentially a responsibility of the state. The Constitution in its 86th Amendment Act 2002 inserted Article 21A to provide free and compulsory education to all children in the age group of 6 to 14 years as a fundamental right. During the third 5-year plan period, almost all states in India have been providing compulsory education to children in the age group of 6 to 11 years of age. In the fourth 5-year plan period, all the states in India were in a position to discharge this responsibility completely. The second responsibility of the state is to provide secondary and higher education. Higher education of all types such as liberal, scientific, technical and vocational are also provided by the state to train the citizens of India for careers in administration, industry, commerce, medicine, engineering and agriculture. Thirdly, the responsibility of the state is to open various schools and colleges. State has opened a number of higher secondary schools, technical institutes, industrial institutes, polytechnics, colleges and special schools for fine arts and for the education of handicapped. The fourth responsibility of the state is to establish state institutes of education. The Education Commission of 1964-66 recommended for the establishment of state institutes of education in all the states of India. The main functions of these institutes will be in-service education of department officers, improvement of teachers in education and preparation of curriculum and textbooks. The other functions will include development of guidance, research and evaluation programs and publication of periodicals on educational problems in modern Indian languages for the use of teachers. The next responsibility of the state is to provide adult and social education. The state has the responsibility of providing education to the illiterate adult citizens of the country to make them fit for democracy. For this purpose, the state maintains a well-organized program of adult and social education. Sixthly, the state is expected to appoint teachers and supervisory staffs. The appointment of supervisors, inspectors and educational officers for regulating the activities of various institutions is carried out by the state. Seventh responsibility of the state is directing and controlling educational activities of the state. The state makes provisions and arrangements to control the educational institutions through different rules, regulations and administrative machineries. Eighthly, to open other training institutions is also a responsibility of the state. The state has taken special care to open various training schools and colleges for providing trained and efficient staff to educational institutions in India. Ninthly, to provide in-service training. The state arranges in-service training programs. The programs are in the form of seminars, meetings, conferences, workshops, refresher courses, summer orientation programs, etc. These programs can be organized by NCERT, SCERT, DIET, etc. It is also the responsibility of the state to provide financial aid to various educational institutions. The institutions that are run by private bodies, local bodies and different people are identified by the state in accordance with a set of rules and regulations. They are then provided with suitable aids and grants to run efficiently and effectively. Certain universities are also given financial aid if required. Another responsibility of the state is to frame curriculum and syllabus. The state has the duty of prescribing syllabus and course of study for various school classes and grades. Rules and regulations for admission, withdrawal and migration are also framed by the state. This is done so that there is coordination and uniformity in all the education institutions functioning across the state. The next responsibility is to hold examinations. Various levels of examinations are sometimes conducted by the state. Some states that do not conduct such examinations give directions to the examination bodies like school boards. Teacher training examinations at the school level, like the junior basic training exams, are also held by some states. The state education departments also award certificates to teachers who have undergone special orientation course at various institutes. Educational functions of the central government. Responsibility of the central government in the field of education has been very important, even though education has remained a state subject. The central government plays a major role in determining the various policies, plans, programs and priorities relating to education in India. Since the provisions for education needs more control, vigilance and guidance, Indian Education Commission enforces the decision to give some authority to the center. The central leadership, especially in the case of education, is essential for a vast country like India. The functions exclusively carried out by the center on education are the following. Firstly, to maintain uniformity in the standards of education in the whole country is a responsibility of the center. Improvement in the quality of education in both public sector as well as private sector is maintained through effective quality assessment systems with the objective of increased international compatibility and competitiveness. This is also done through introduction of major reforms at private universities like those introduced in public universities. Secondly, to lay down the general policies of education to be carried out by the state government. One of the principal roles of the central government is the formation of policies that the state government ought to implement. Another responsibility of the central government is to give guidance to the state government in carrying out these policies. After the formation of policies, the center supervises the same and coordinates them to give guidance to the state. Fourthly, to act as a coordinating agency. In order for the policies to be formulated and implemented in the right way, the center acts as a coordinator for the state. Next responsibility of the central government is to sponsor developmental programs. The Indian education system recognizes the role of education and thus comes with the implementation of developmental programs. The sixth responsibility of the central government is to collect and disseminate various ideas and information related to education. Existing provisions of the Constitution should be exploited for the development of education and evolution of a national educational policy. Central leadership for the states is essential for a vast country like India. Another responsibility of the central government is to level out the differences between different states and ensuring quality of opportunity. Here, the center takes the responsibility to equalize educational opportunities between different states also. It is also the responsibility of the central government to appoint commissions to take survey on all India educational problems. Recognizing the role and importance of education, all India commissions are deployed. For example, there is the Department of Education, Surveys and Data Processing, and there are survey officers appointed for carrying out certain projects. Next, to provide financial assistance to the less advanced states. While Government of India provides for free and compulsory education, there is additional cost to education for every state, such as examination fee, books, stationery, etc. To help ease the burden of financial costs to less advanced states, the central government provides aid. The central government had also introduced the Prime Minister's 15-point program for welfare of minorities, enhancing opportunities through improved access to school education and scholarships for meritorious students from minority communities of different states. It is the responsibility of the central government to provide financial assistance to the scholars from within and outside the country. Another responsibility of the central government is to maintain educational and cultural relations with other countries. The Indian Council for Cultural Relations, or ICCR, is an autonomous organization of the government established in 1950. The organization has an administration and education wing to cater to educational and cultural relations with other countries. The body also administers scholarship schemes for foreign students for studies in India. Other responsibilities of the central government are to stand a channel of communication with UNESCO, UNICEF and the World Bank, to start institutions of Indian importance, to recruit faculty for its own institutions, to send delegations abroad, to invite scholars from abroad, to carry out new experiments and research in the field of education, to start pilot projects in the field of education, and to answer questions in the Parliament regarding education. Joint functions of both centre and state. The 42nd Amendment of the Indian Constitution has made provisions for concurrent functions in 1976, which means that both centre and the state are responsible for certain provisions relating to education. In the book The Role of Government of India in Education, J.P. Naik mentions the concurrent functions of the centre and the state as follows: technical education, scientific research, education of minorities, education of scheduled caste and scheduled tribe, education of the handicapped, university education, advanced professional and vocational training, education for emotional integration, promotion of educational research, and the provision of free and compulsory education up to the age of 14. Many of the thinkers and educationalists agree with the inclusion of education in the concurrent list. In 1948-49, the University Education Commission stated that education should be the responsibility of both the centre and its constituents. The responsibility of centre will also cater to sectors like technological research, universalization of elementary education, equalization of educational opportunity, and improvement of educational standard. Advantages and disadvantages of the state taking control of education. Thinkers and politicians have always been debating upon the state control of education being desirable or not. If the state takes complete control over education, there are many advantages, such as there would be uniformity in the process of education, there would be uniformity in the standard of education, educational institutions would be free from economic difficulties if state would be ready to provide subsidy, education would be free from local struggles and quarrels, teachers in the educational institutions might develop a feeling of security when state takes the control of education, state control over education will help preserve national culture, etc. Many educationalists are in favor of increasing the authority of the state for many reasons. They feel that if the centre has supreme powers, the state would loosen their initiative for educational developments in their region. Not every state will tolerate the interference of the centre in their affairs. The people in favor of this argue that state would be losing their initiative in raising resources for implementation of various educational programs if education becomes a central or concurrent subject. In a democratic state like India, the state should have greater autonomy in implementing its own developmental programs is yet another argument. There are disadvantages of this system also. They are the following. India being a democratic country, education can become a powerful instrument in the hands of the ruling party. The aim of education can become narrow if the state would declare a policy of its own regarding education. Advantages of placing education in the concurrent list. Educationalists who support placing education in the concurrent list do so because they feel that for a uniform educational policy and national system of education, it would always be better if the centre provides effective leadership to the states. This also helps in minimizing the regional imbalance in educational development, which is possible if education is placed in the state control. The centre will have more responsibility in providing equalization of educational opportunities and creation of egalitarian society. According to the support, unless the centre has the adequate authority, it is difficult to implement the national policies, priorities and programs relating to education. They also feel that the resources of the state are too meagre to provide for development of education in the desired directions, whereas the resources of the center is so vast and it can help in raising adequate funds required for educational developments. Last and not the least, they say that the role of the center is very vital for promoting national integration through education. Let us summarize what we have discussed so far. Role of Government of India in education is one of the major educational controversies of today. The sudden quantitative change and expansion of education in different levels has brought the education administration face to face with local community, posing new challenges. The state control and center control over education is much debated upon. In a country like India with a wide range of diversity in different aspects, the state-center relationship in education is very critical. At the same time, there have always been controversies as to who would do that. Under Article 42 of the Constitution, an amendment was added during 1976. Education in India has been added in the concurrent list, which means that both the state and the central government will perform the educational functions. In the 7th schedule, Article 246 of the Indian Constitution, there is a division of powers between center and the state. The session clearly states the educational functions of the central government and that of the state government. Furthermore, the joint functions of both the center and the state are also discussed. Now, you can try to answer the following questions. Which are the educational provisions relating to education in the Constitution of India? What are the educational functions of the state government? What are the educational functions of the central government? What are the joint functions of both center and state related to education in India? What are the advantages and disadvantages which the state take control over education in a country like India? Now, you may go through the reference books given here. Foundations of Education by O.P. Dhimman, published by A.P.H. Publishing, New Delhi, in the year 2008. Education in India, Problems and Perspectives by M. Dash, published by Atlantic Publishers and Distributors, New Delhi, in the year 2004. The Role of Government of India in Education by J.P. Naik, published by Ministry of Education, India. Thank you for watching the program. We can meet again with another topic soon. Till then, take care.
Hello, welcome to the topic Approaches to Educational Technology. The term technology implies the application of science to art. Technology in education is the application of technology to any process of educational enterprises, or otherwise it is the use of technological advancement like the various equipments, materials and machines for educational purposes. Education technology is the study and ethical practice of facilitating learning and improving performance by creating, using and managing appropriate technological processes and resources. Education technology, especially computers and computer-related peripherals, have grown tremendously and have permeated all areas of our lives. Teaching is changing. It is becoming a more difficult job because of increasingly numerous contradictory expectations, including the following. First, teachers are evaluated by their ability to have students pass tests that often give no value to these abilities. And we are living in an age of information overload with the expectation that students will learn high level skills such as how to access, evaluate, analyze and synthesize vast quantities of information. And also teachers are expected to teach students to solve complex problems that require knowledge necessary across many subject areas. And teachers are expected to meet the needs of all students and move them toward fulfillment of their individual potential. Technology can actually assist with some of these expectations and make teaching and learning more successful. Technology has been proved to accommodate learning styles and to be an effective motivator for students with specific learning needs. Furthermore, students working in collaborative team learning settings appear to function better when learning events are accompanied by technology use. Different people view the development and use of modern educational technology in different ways. Some consider it has the basis of a revolution in educational system aimed at improving the effectiveness and efficiency of education at different levels. Some think that it replaces the traditional teacher from the scene of teaching by use of sophisticated machines and gadgets. In reality, education technology defines teaching objectives in behavioral terms. It is that science on the basis of which various methods and techniques are developed and constructed in order to achieve predetermined teaching objectives. Education technology creates conditions by interpreting the input during the teaching process. It selects and applies the appropriate strategy for achieving the teaching objective. There are three main approaches to studying educational technology. It was A. Lemmerstein who first classified education technology into three types or approaches in the year 1964. First, hardware approach, and second, software approach and systems approach. Module 2, hardware approach of educational technology. Hardware approach originated from physical science and engineering. This approach is a byproduct of scientific and technological development of the 20th century. Hardware approach is based on concept of service. It is concerned with utilizing audiovisual aid materials like charts, models, slides, film strips, audio cassettes, audio CDs, etc. The hardware approach also makes use of sophisticated gadgets and instruments for educational purpose. The technology used including radio, television, gramophone, films, tape recorders, projectors, video players and machines that aid in teaching, computers and mass media. All the teaching mechanics used in a hardware approach makes teaching more effective in order to achieve outstanding teaching objectives. This type of educational technology adopts a product-oriented approach. This means that hardware technology utilizes the products of software technology for its functioning. The products of software technology can be teaching strategies, teaching learning materials, etc. Thus, it utilizes software technology for the betterment of the process of teaching learning. With greater ease and economy, the hardware technology has the ability to hand over the educational benefits to the mass. It is thus the application of physical science in education and teaching in education with which the teaching process is being mechanized gradually so that maximum pupils may be educated in minimum time at very low cost. Human knowledge has three aspects: preservation, transmission and development. The history of preservation of knowledge is believed to exist since the time of printing machines. At that time, the knowledge was preserved in the form of books. The knowledge was also preserved through tape recorder and films. Another aspect of human knowledge is its expansion and transmission. It is now supported by machines like radio, television, mics, etc. Education technology has brought tremendous change in this field. the correspondence courses and open universities are the gifts of hardware approach. The third and last aspect of human knowledge is its development. Provisions are made for research in this aspect. This includes collection and analysis of data. For this purpose, they use the computers and other electronic devices. So, it is clear that all the aspects of human knowledge allow the use of machines. This mechanized way of teaching process is the hardware approach of educational technology. Hardware approach in education technology helps for knowledge explosion, thus leading to an overall efficiency in the educational system. Module 3. Software approach to educational technology. Software approach is also known as behavior technology or instruction technology or teaching technology of behavior technology. Its origin is in behavior sciences and applied aspect of psychology of learning. It is a process-oriented approach. In software approach, psychological principles of learning are utilized so that desirable changes may be brought about the behaviors of those learning. It utilizes the knowledge of the psychology of learning to produce learning material, teaching, learning strategies, etc. This means that it is related to or concerned with teaching objectives in behavioral terms, principles of teaching, methods of teaching, method of teaching and techniques, reinforcement of instructional system, feedback devices and evaluation. This approach is characterized by task analysis, writing objectives in behavioral terms, selection of appropriate learning strategies, reinforcement of correct responses and constant evaluation. In software approach, the psychology of learning is exploited for the production and utilization of software techniques and materials in terms of learning materials, teaching learning strategies, tools of evaluation and other devices to soften and smoothen the task of teaching and learning. This method has thus tried to develop all the three aspects of input, process and output. Here direct device to the usage is not provided. Instead, it helps in production of various software materials which are used for developing hardware appliances, which include teaching strategies, learning material, evaluation tools, teaching models, programmed instructions, etc. Software technology does not require any aid from the hardware technology for its delivery. It becomes more useful and productive when assisted by hardware technology. It does not have a mass appeal and it costlier to run than hardware approach or hardware technology. During World War II, instructional technology was used effectively. With the problems of labor shortage, this method provided a methodology for training in a systematic and efficient manner in United States. Followed by this came to the use of highly structured manuals, instructional films and standardized tests. Behavior technology is a growing field of study now, which uses technology as a means to solve educational challenges both in the classroom and in distance learning environments. The software approach or instructional approach creates an active environment in which students not only inquire but also define problems of interest to them. Such an activity would integrate the subjects of technology, social studies, mathematics, science and language, arts with the opportunity to create student-centered activity. Multiple representations and enhanced visualization will improve their skills and concepts embedding them. The benefits of software approach includes increased accuracy and speed in data collection and graphing, real-time visualization, the ability to collect and analyze large volumes of data and collaboration of data collection and interpretation, and more varied presentation of results. Traditional teacher-centered approach in the classroom has been shifted from teaching to learning. It is called student-centered or resource-based approach, the student being the resource. Learning through hearing alone proves to be the least effective means of learning. Technology is a sum total of teaching, instruction, education, learning and engineering, which helps to shape the personality of the learner in a meaningful context. While hardware approach means the use of machines in teaching, the software approach means the use of teaching and learning principles. Objectives of software technology or instructional technology include to determine the goals and formulate the objectives in the behavioral terms, to analyze the characteristics of learner, to organize the content in logical or psychological sequence, to media between content and resource of presentation, to evaluate the learner's performance in terms of achieving educational objectives, to provide the feedback among other components for the modification of learners. Module 4, Systems Approach to Educational Technology. Systems approach is also known as management technology. A system is a set or arrangement of things so related or connected as to form a unity or organic whole. These components, parts or elements of the system are intimately linked with one another, either directly or indirectly, and any change in one or more elements may affect the overall performance of the system. Thus, it is a regular, orderly way of doing things. So, systems approach is a set of things working together as a mechanism or interconnecting network. Developed after World War II, the systems approach has provided a scientific basis to the decision making regarding the problems associated with administration, management, commerce, industry and army. System approach is a systematic way of designing, implementation and evaluation of a process in terms of its desired objectives. System approach involves accurate identification of the requirement of problem. It is the setting of objectives after identifying their needs in performance-oriented terms. It is the application of logic and analysis of techniques to the problems. It is the development of methods for the solution of the problems and rigorous measurement of the product against specific performance objectives. It helps in development of educational administration and formulation of instructional outline. Educational administration and management can be made effective and less costly by using in educational system. Schools are viewed globally as social systems. Instruction and teaching are considered as subsystems of that system. Classroom, faculty, student groups, informal groups, etc. are other subsystems within. Education is considered a complex organization of technical, managerial and institutional systems. This instructional system has three parts: the instructor, the learner and the goals of instruction. The system approach to education thus considers education as an input-output system. Systems approach to education emphasizes identifying and stating the goals to be achieved, and identifying the processes, methods, techniques and strategies that may be most relevant to achieving the predetermined goals. And thirdly, building up theoretical foundation justifying the relevance of these processes to achieving the goals. Determining specific interactions visualized existing among various other components of inputs. specifying the various kinds of controls needed in the total system of different points. Keeping the whole in mind all the time while preparing the model or the system. The systems approach to course and curriculum design is no more than an attempt to use a process of logical development and ongoing monitoring and evaluation in order to allow continuous evaluation of the course or curriculum to take place. In implementing the systems approach, it is important to appreciate that while the decisions taken at each stage are always affected by earlier decisions, they may themselves necessitate some of these earlier decisions being changed. It is also important to realize that the stages shown are not the only ones possible, and that once taken, a decision can always be reconsidered. The approach should thus be dynamic and iterative, always allowing for second thoughts and the refinement of ideas. For example, although you should certainly make a first attempt to define objectives and learning outcomes very early in the planning, you will invariably need to come back to redefine or add to them once you have worked through some of these later steps. The systems approach can be used at any time when an episode of teaching learning of any length is being planned. It can be applied to long-term planning for a whole course lasting weeks, months, or years, through the daily lessons planning, or even to on-the-spot planning for a learning experience of only a few seconds duration. It can be applied by a group of teachers designing or adapting a complete course, as well as by an individual teacher preparing or his or her specific course input. The approach can also be used for analyzing a previous teaching or learning experience. The systems approach does not prescribe or promote any particular teaching methodology, for example, individualized study or group learning. Rather, it is a vehicle that helps teachers to think more systematically and logically about the objectives relevant to their students and the means of achieving and assessing these. On occasion, analysis may suggest that chalk and talk may be the most appropriate method for achieving some objectives, but no one method will be appropriate for all objectives or for all students. There are various stages in systems approach. They are the following. First, considering target population, characteristics and topic area. The range of backgrounds, interests, knowledge, attitudes and skills of students coming to take up the course will have a strong influence on course design. Pre-knowledge and any common misconceptions will have to be catered for in the design of the course. Consideration should be given to the sort of people with whom the course has been developed. The subject area may have traditional aims and directions, but there should be a provision for future change. And secondly, estimation of relevant existing skills and knowledge of learners. There should be minimum standard of entry to the course. They should possess skills and qualities which will have an influence on course design. Thirdly, formulation of objectives or learning outcomes. The objectives and learning outcomes of the course or curriculum element will attempt to encapsulate the new skills, knowledge or attitudes which it is intended that the students will acquire. They may be formulated by the learners themselves, by employers, by teaching staff, examining or professional body, or by some combination of these and other sources. Selecting appropriate instructional methods. the process of attempting to match appropriate methods to given objectives and learning outcome is normally done on the basis of a combination of research and experience. The strengths and weakness of different methods should be well known. Operation of course or curriculum. The next element in the system is the actual implementation of the course. This involves all the logical arrangements associated with running the course, including overall structuring, pacing, implementing the chosen teaching strategies, using appropriate supportive media and materials, and ensuring that all aspects of the course run as smoothly as possible. Assessing and evaluating. The combined result of the preceding stages in that students are involved in a learning experience that is planned to develop their knowledge, skills and attitudes, taking into account the individual needs and experience of the learners. Just how effective the pre-planning and subsequent operation has been can be measured by studying student performance in continuing and post-course assessments. These assessments should be closely related to the specified course objectives and learning outcomes. Poorly achieved objectives or learning outcomes should lead the course designers to examine the entire system in order to identify places where improvements might be made. This might finally lead to making a change in objective, revising the assessment of students' pre-knowledge and thorough examination of the course structure and organization. Let us summarize what we have discussed so far. The chapter focuses on three-tier approach of education technology. The three approaches were first suggested by A. Lemmerstein in the year 1964. The three categories of education technology are software approach, hardware approach and systems approach. Hardware approach is the application of physical science in education and teaching in education, with which the teaching process is being mechanized gradually so that maximum pupils may be educated in minimum time at very low cost. Software approach use psychological principles and learning theories in education. In software approach, the psychology of learning is exploited for the production and utilization of software techniques and materials in terms of learning materials, teaching learning strategies, tools of evaluation and other devices to soften the task of teaching and learning. Systems approach involves accurate identification of the requirement of the problem. System approach is the setting of objectives after identifying their needs in performance-oriented terms. Educational administration and management can be made more effective and less costly by using in educational system. The systems approach to the design and analysis of teaching or learning situations is the basis of the great majority of modern educational technology related developments.
कदाचित् कुप्यन्ति जितालङ्घनपाचनैः ये संशोधनैः शुद्धा न तेषां पुनरुद्भवा शोधनस्य प्रधानत्वात् आयुर्वेदं महत्तरम्
Ayurveda, the science of life. The seers and sages of the Vedic period evolved and perfected it. And Ayurveda, a time-tested system of medicine, remains relevant even today. It continues to use traditional practices to relieve the patients of their sufferings. Ayurveda draws heavily from nature. To us, these slimy leeches are bloodsuckers, but for the Ayurvedic surgeons, they are surgical tools. They are used to let out blood in a surgical practice called leech therapy.
Ayurveda, the age-old Indian healthcare system, has two schools. The medical school developed by Charagacharya and the school of surgery, that is Shalyatantra, propounded by Sushrutaracharya. Raktamoksha or bloodletting is one of the methods of surgery advocated by Sushruta, where a certain quantity of blood is removed from human body in an attempt to relieve the patient of certain illness. The Jaluka Vajaram or leech therapy is the most common method of bloodletting now used in Ayurveda.
References to bloodletting using leeches can be found in ancient Ayurvedic texts like the Susruta Samhita and Charaka Samhita. These texts identify 12 distinct types of leeches. 6 of them are toxic and 6 non-toxic. Leeches belong to the phylum Annelida and class Herudinae. In Sanskrit, they are referred to as Jalukas, or those that dwell in water. Toxic leeches are not used for therapeutic purposes. These are identified by their dark red or black color, sticky or hairy body, and in some, by the markings on the body. Non-poisonous leeches are found in freshwater sources. From such natural habitat, leeches are collected and kept in clean containers. Here at the Kottakkal Vaidyaratnam P.S. Warrior Ayurveda College in Kerala, doctors use leeches to treat boils, non-healing ulcers and skin diseases like eczema. Leeches are used to suck out impure blood that remain clotted in the afflicted parts of the body. There are 3 stages in the Jaluka Vajrana: Purva Karma, the Pradhan Karma and Paschat Karma. The Purva Karma or the preparatory stage consists of cleaning the leeches in 2 phases. Initially they are washed in turmeric water, a natural antibiotic. They are then transferred to pure water for further cleaning. Now the leeches are active and ready to suck the impure blood. The Pradhan Karma or the main surgery begins with the application of the leech on the affected part. Usually it attaches itself and makes an incision on the skin with its jaws. If it fails to cling on to the afflicted spot, the spot is pricked to attract the leech to the oozing blood. An anticoagulant named Hirudin injected by the leech ensures smooth blood flow, and Himentin, an enzyme excreted by it, acts as an anesthetic, preventing any pain. The rhythmic pulsations on the neck indicates the progress of blood being sucked. The leech's body is covered with wet cotton to give it a feeling of its natural environment. It is also kept soaked by sprinkling water. Once the sucking of impure blood is complete, the leech usually detaches itself. But if it continues to suck, a bit of turmeric or lime is applied. This makes the leech disengage itself from the afflicted area. The third phase of Jaloka Vajranam begins with the cleaning of the spot. If bleeding persists, the wound is dressed with Ayurvedic healing agents.
Not just the limbs, leeches can also be applied to the sensitive parts of the body. Though it is unnerving to see leeches being applied to the more delicate organs such as the eyes, the results it gives are amazing. There will be immediate relief from disease symptoms such as pain and swelling without the fear of a surgery, as Kasmi, one of the patients, testifies.
കണ്ണ് നല്ല ചുവപ്പുണ്ടായിരുന്നു. അങ്ങനെ കണ്ണ് നീക്കാൻ കഴിച്ചില്ലായിരുന്നു. പിന്നെ അങ്ങനെ വിരിപ്പ് വന്നി കുറച്ച് കഴിഞ്ഞതിന് ശേഷം. അങ്ങനെ ലോട്ടറി വന്നപ്പോൾ ഇവിടെ വന്ന് കാണിച്ചപ്പോൾ മൂപ്പര് നോക്കുമ്പോൾ അങ്ങനെ ചുവപ്പ് വേറെ അങ്ങനെ കുരിപ്പ് വന്നിരുന്നു. അങ്ങനെ അതിൻ്റെ അട്ടണ പിടിപ്പിച്ച് പിന്നെ 2 ദിവസം കഴിച്ചപ്പോൾ മാറി. അപ്പോൾ അസുഖം വേറെ വേദന ഒന്നും കാര്യങ്ങളൊന്നും ഉണ്ടായിരുന്നില്ല.
These are the little surgeons of nature, equipped with their own surgical kit, anticoagulants and anesthetic agents. They provide relief to many ailments naturally, without the complications of conventional surgery.
Hello and welcome to a session on Introduction to Videography, Understanding the Image Sensors. The camcorder is a video camera and a video recorder in one. It has 3 major components: the image sensor, the lens system and the recording part. Now in this session we are going to focus the image sensor part of the camcorder. The upcoming sessions will discuss on the lens system and the recording part of the camcorder in detail. Let's look through the image sensor. The image sensor. When an image is being captured by a video camera, light passes through the lens and falls on the image sensor. The image sensor consists of picture elements, also called pixels, that register the amount of light that falls on them. They convert the received amount of light into a corresponding number of electrons. The stronger the light, the more electrons are generated. The electrons are converted into voltage and then transformed into numbers by means of an AD converter. The signal constituted by the numbers is processed by electronic circuits inside the camera. The type of image sensor in a camera greatly affects the quality of the image in its resolution, picture defects and limitations. Before the camcorder, all cameras were installed with a special camera tube such as the Vidicon and the Saticon, etc. This meant they were big and heavy and consumed a lot of power. They could not cope with intense light sources as these caused streaks on the image. Glaring lights or clearly lit objects became part of the image and remained there into the next shot. Understanding CMOS and CCD image sensors. Cameras capture what we see with the help of image sensors, the 2 most common types being CMOS sensors and CCD sensors. These competing technologies have provided camera manufacturers with 2 different methods for capturing images for the past decade or so. These image sensors are used to produce the digital images during recording. Both types are made of silicon and use similar mechanisms to process images, but each type uses different technology to capture and transfer image signals, and some users find that there can be a significant difference between the end results. A CCD video camera and a CMOS video camera have different processing efficiencies, different qualities, different paired accessories, and are even different prices. Understanding how each type of sensor works and the strengths and weaknesses of each helps buyers determine the technology that is suitable for their video camera needs. Charge coupled device, that is CCD. The CCD video camera has been the go-to sensor since its development. In a CCD video camera, light hitting the image sensor is converted to an electrical signal. This electron packet must then be transferred 1 pixel at a time through an output node to an image processor, at which point it is converted to voltage. The voltage is then buffered and sent out from the chip as an analog signal. The CCD is small, compact, rugged, and consumes a low amount of power. Camera tube has been replaced by a special chip, a semiconductor image sensor. This image sensor is called a CCD, that is charge coupled device. In a CCD sensor, the light, that is the charge that falls on the pixels of the sensor, is transferred from the chip through one output node or only a few output nodes. The charges are converted to voltage levels, buffered and sent out as an analog signal. This signal is then amplified and converted to numbers using an AD converter outside the sensor. The CCD technology was developed specifically to be used in cameras, and CCD sensors have been used for more than 30 years. Traditionally, CCD sensors have had some advantages compared to CMOS sensors, such as better light sensitivity and less noise. In recent years, however, these differences have disappeared. The disadvantages of CCD sensors are that they are analog components that require more electronic circuitry outside the sensor. They are more expensive to produce and can consume up to 100 times more power than CMOS sensors. The increased power consumption can lead to heat issues in the camera, which not only impacts image quality negatively but also increases the cost and environmental impact of the product. Used for a number of years in video and still cameras, CCDs long offered superior image quality to CMOS sensors with better dynamic range and noise control. To this day, they are used in budget compacts, but their higher power consumption and more basic construction has meant that they have been largely replaced by CMOS alternatives. They are, however, still used in medium format backs, where the benefits of CMOS technology are not as necessary. CMOS, complementary metal oxide semiconductor image sensors. Digital cameras have become extremely common nowadays, as it is affordable too. One of the drivers behind the falling prices of digital cameras has been the introduction of CMOS image sensors. CMOS sensors are much less expensive to manufacture than CCD sensors. With more functionality built on chip than CCDs, CMOS sensors are able to work more efficiently and require less power to do so, and are better suited to high-speed capture. CMOS chips have several advantages. Unlike the CCD sensor, the CMOS chip incorporates amplifiers and AD converters, which lowers the cost for cameras since it contains all the logics needed to produce an image. Every CMOS pixel contains conversion electronics. Compared to CCD sensors, CMOS sensors have better integration possibilities and more functions. However, this addition of circuitry inside the chip can lead to a risk of more structured noise, such as stripes and other patterns. CMOS sensors also have a faster readout, lower power consumption, higher noise immunity and a smaller system size. Unlike CCD sensors, CMOS sensors have circuitry at the pixel level. This means that every pixel on the sensor is read and transmitted simultaneously, preparing voltage for the chip. The chip then uses additional technology such as amplifiers, noise correction and digitization to convert the voltage to digital data. This means that CMOS sensors do not require a separate image processor because CMOS sensors are able to convert visual information to digital data more quickly than CCDs. They require less power, which preserves battery life. However, the extra technology on the sensor crowds the pixels, limiting their ability to capture light and resulting in generally poorer visual clarity in the final image. CMOS sensors are commonly designed with rolling shutters, especially on commercial applications. This means that the image frame is exposed from one side to the other, instead of all at once as on CCD sensors. For example, a video camera using a CMOS sensor may record data in a rolling sweep from left to right or top to bottom. This results in the potential for a few types of distortion not found on CCD sensors. Since their inception, both types of sensor technologies have landed in a wide range of cameras, but CMOS sensors seem to be increasing in popularity. The Red Epic's New Dragon sensor is actually a 19.4 megapixel CMOS sensor capable of shooting up to 6K. Sensor artifacts. Sensor artifacts refer to the alteration of digital imagery in a frame as a result of the video process. The types of artifacts produced by CCD and CMOS sensor vary due to their different shutter types. Keep in mind that there is no physical shutter on digital cameras as there would be on a film camera. The shutter instead indicates the sensor's designed exposure method. Remember that CCDs use a global shutter while CMOS sensors in commercial products use a rolling shutter. There are 4 primary types of artifacts. The first 3 are applicable only to rolling shutters, that is CMOS cameras, while the 4th smear FX global shutters, CCD cameras. Keep in mind that some new CMOS cameras such as the Sony Pregus offer CMOS technology with a global shutter. Skew. Skew only occurs on CMOS cameras with rolling shutters. This artifact occurs when the camera or subject is moving swiftly during exposure. Because the rolling shutter records data from one side to the other, an object that has moved position between the start and end of exposure will appear to occupy multiple places within the image. For example, a person running across the frame of a camera that records from top to bottom may appear to have his lower body stretched out in front of his head and upper body as the camera recorded the lower body in a moment after the upper body. Wobble. Wobble is similar to skew and results from instances in which the video camera is shaken or affected by other sudden motion. It is a common artifact in videos from handheld cameras. Images affected by wobble may appear to be stretched or sometimes duplicated. This is also commonly referred to as the jello effect. Wobble occurs only in a CMOS camera with a rolling shutter. Partial exposure. Partial exposure occurs when a flash of light, such as a camera flash or lighting bolt, is caught in the shot. The rolling shutter may only capture the light produced in part of the image, leaving the remainder dark. This can result in images that appear split with a portion of the image lit more clearly than the other and divided by a sharp line. Like skew and wobble, partial exposure only occurs on CMOS cameras that use a rolling shutter. Smear. Smear is a type of CCD artifact that occurs as a result of a bright spot within an image. The intense light causes the column of pixels to appear white or washed out on the exposed image. These columns or streaks of light often appear in images of headlights or any direct video of a light source. Smear can also occur in a CMOS camera with a rolling shutter. CCD versus CMOS. Which is better? CCD, that is charge coupled device, or CMOS, that is complementary metal oxide semiconductor? It depends, as there are advantages to both sensor technologies. For most applications, CMOS provides a better choice, but in others, CCD continues to hold its ground. Both use semiconductors to convert light into electrical signals. In a CMOS sensor, each pixel has a photoreceptor performing its own charge to voltage conversion and typically includes amplifiers, noise correction and digitization circuits, enabling the sensor to output digital data directly. The pixels typically don't store any charge. They simply read how much light is hitting that pixel at a particular moment and read out progressively from top left to bottom right, line by line, while the shutter is open. In a CCD sensor, light enters the photoreceptor and is stored as an electrical charge within the sensor, then converted to voltage, buffered and sent out as an analog signal with the shutter closed. A strong advantage for CMOS technology is that it provides digital output and can be controlled at the pixel level in ways that are not possible with CCDs. This provides potentially huge advantages in specialized imaging, where one might want to apply partial scanning or a particular control process to only a segment of the sensor. This capability is useful for control of cameras in different imaging modes for multispectral imaging or binning. CCD advantages over CMOS are the sensor's higher quantum efficiency, that is QE, and generally lower noise. The proportion of each pixel dedicated to light gathering versus being masked for other functions is also comparatively high. However, CCD cameras generally consume more power than CMOS, which can be a consideration for certain life science applications or for cameras which are battery powered. Blooming is an unwanted CCD specific artifact which appears as a vertical smear line when a bright light or saturation occurs in the image. Probably the most significant issue when deciding between CCD or CMOS is global versus rolling shutter. Most CMOS sensors today use a rolling shutter which is always active and rolling through the pixels line by line from top to bottom. CCDs on the other hand store their electrical charges and read out when the shutter is closed and the pixel is reset for the next exposure, allowing the entire sensor area to be output simultaneously. When the shutter is open, the CCD receives light and accumulates charges again. The videography markets are in a state of transition from CCD cameras to CMOS largely in part due to economies of scale in CMOS manufacturing. If you have wondered why camera makers are all using CMOS over CCD cameras, it's simply because the end users prefer them because of cost, size and convenience. Hopefully, this article has helped those wondering what a CMOS camera is or means. It's just the type of image sensor. Conclusion: CCD and CMOS sensors have different advantages, but the technology is evolving rapidly and the situation changes constantly. Hence, the best strategy for a camera manufacturer is to continually evaluate the test sensors for each and every camera that is developed. The question whether a chosen sensor is based on CCD or CMOS technology then becomes irrelevant. The only focus is if the sensor can be used to build a network camera which delivers the image quality needed and fulfills the customer's video surveillance requirements. Let us summarize what we have discussed so far. Choosing the correct task. Varied applications have varied requirements. These requirements impose constraints that affect performance and price. With these complexities at play, it is not surprising that it is impossible to make a general statement about CMOS versus CCD imagers that applies to all applications. CMOS and CCD image sensors convert images, that is light, into electronic signals. CCD sensors are slightly cheaper and are the older, more mature technology. CCD and CMOS sensors are susceptible to different problems. CCD sensors are more susceptible to vertical smear from bright light sources, while CMOS sensors are susceptible to skewing, wobbling and partial exposure. However, neither technology is a clear winner over the other in overall image quality. In spite of the significant advances in CMOS image sensor technology and design, the smaller pixel size and generally better low light performance of CCDs remain as the main obstacles toward their general adoption. We expect that further scaling of CMOS image sensor technology and improvements in their imaging performance will eventually erase any remaining advantage of CCDs. More importantly, we expect that many new and very large markets for imaging devices will be created by further exploitation of the integration of sensing and processing. Now, you can try to answer the questions given here. What's the difference between CMOS sensors and CCD ones? CCD still has some advantages over CMOS technology. What are they? What do you mean by smear? What is rolling shutter? What are sensor artifacts? Compare the output quality of video both in CCD and CMOS technology. Hope that you may go through the references for further reading. Video Prediction Handbook, 4th edition, authored by Millers and G, published by Focal Press at Elsevier, 2009. Next, Video Prediction 101, Delivering the Message, authored by Manriquez A, Peach Pit Press, 2014. Next, The Art of Video Prediction, authored by Shailesh L, Sage Publications in 1998. Thank you for watching this program. We can meet again with another topic soon. Have a nice time.
Welcome to Interface. Today we have Professor Hans Eugen Wollersheim from GSI, Germany with us. Welcome to this program.
Thank you very much.
Professor Hans is one of the active collaborator of FAIR project to be built at GSI in Germany. As an international collaboration team, make a big accelerated complex and it will deliver heavy ion beams in 2020. Can you explain to us what is this FAIR collaboration?
Okay. So FAIR is a facility for ion and antiproton research in Germany, and the place is very close to Frankfurt. And what we will do is we will accelerate heavy ions, stable heavy ion beams, and then by a nuclear reaction we will then produce the radioactive ion species. So ions are just atoms where a few electrons are removed so that they can be accelerated in an electromagnetic field.
Can you tell us what will be the highlights of this facility?
Yeah, the highlights are the investigation of the nuclear matter, because the nuclear matter is made from protons and neutrons, and they have an extremely high density and very unusual in nature. So as you would investigate iron or lead, you would just use a hammer and bang on this material, and in this way we bombard, let's say, these heavy ions onto other nuclei of the same kind, and then the nuclear matter is compressed, and then we know how hard the matter is, and then we will put temperature on these ions. This is excitation energy, or we will fast rotate the ions so that we know when they will rupture. And finally we will change the proton to neutron ratio. This is in our case called the isospin, and in this way we hope to learn a little bit more about the nuclei. And remember, these atoms do not only exist in this laboratory. When you go to the neutron stars, you will see macroscopic objects of these properties. So a neutron star, for example, has a diameter of 10 kilometers. So you can see what we are doing in the lab. This can also be found in nature.
So how do you compare the present or upcoming facilities with FAIR? How do you compare
the old ones with the new
present accelerator facilities?
Oh, the present one, yeah.
Present accelerator facilities or upcoming ones, yeah, with the FAIR project.
Yeah, we will increase the beam intensities by 3 orders of magnitude, so a factor of 1000. Now you have to imagine, right now we can only get a rough estimate what will happen, let's say, when we go to very neutron-rich isotopes, and when we have an increase in sensitivity, especially also with the detectors which we are using right now, then we can get much more insight into the nature than compared to the present facility. The present facility, GSI, is called Society for Heavy Ion Research.
Okay. So you said about existing facilities and forthcoming facility. So how do you compare with the LHC or one with the RI beam factory in Riken? How this facility will be different from these two?
Yeah, LHC is completely different. Here you use a proton beam, and in this way you can investigate the microstructure of the proton and of the neutron. Riken is more or less the same facility as at GSI, but they have much lower beam energy, and therefore they cannot really investigate the heavy elements. So what we are doing is we can accelerate all the elements from proton to uranium and in this way we can produce all the isotopes which will exist from the existing isotopes until the very neutron-rich and proton-rich nuclei.
So, what type of preparations at GSI is going on, or other labs also going on in preparation for this FAIR project?
Yeah, several experiments have been performed before the FAIR project was agreed on. For example, I was responsible for a big gamma-ray spectroscopy experiment, and with old-fashioned germanium detectors we could get very nice results, approximately 150 publications we could publish, and so we have a good insight into this field. So we are really looking forward now with the new detectors, with the new accelerator, to perform similar experiments.
Professor Hans has been in India for some time. He has a visiting professorship at IIT Ropar in Punjab and stalwart of the nuclear structure experiments in India and Germany. So can you share with us your experiments in India and also your sabbatical position at IIT Ropar?
Yeah, since 2004 I'm working in India, so I'm really working at the present accelerator facilities, and is a marvelous experience for me to work with my Indian colleagues. It is all the experiments which we performed here were all published and accepted by all the international journals. So you are really working here in India at the top of the nuclear physics research field, and you can really be proud of the facilities you have here in India. So besides this, I mentioned already, I was heading a research group in GSI, and we have usually 2 Indian members in our group, and we are also educating, let's say, the PhD students which come to Germany. So it's really an international team which we had together for quite some time. So it is really a pleasure to work with Indian students as well as with the Indian colleagues.
What about IIT Ropar?
IIT Ropar, this is an upcoming IIT. So I got this position as a visiting professor in order to help the physics division to select Indian lecturers, associate professors for the IIT, and it is really a pleasure for me to help them and to form a really very strong department there, so that research can be at a very, very high level.
With the FAIR facility, what type of surprises do you expect?
You see, in the 1950s, the shell model was discovered, and also a Nobel Prize was given to this. Now, in the meantime, we have found evidence that these theoretical studies are not valid anymore for the neutron-rich nuclei. So many corrections have been made already for this model, and we are really looking forward what will happen with the new results. And I'm pretty sure that a lot of surprises in this field will happen, and we will be getting surprised when we get the experimental results. New radioactivity has already been seen, so we have proton radioactivity, we have proton radioactivity from excited states, and on the neutrons rich side, where all the elements are produced, we have not done so much research because our present facility was not able to go to these neutron-rich nuclei. So as I mentioned before, a factor of 1000 will give us many steps into the direction of the neutron side, and then we will also see neutron radioactivity. So the nuclei will not only decay via beta decay, but also by neutrons, and we have to understand the natural abundance of the elements on Earth, and this can only be done when we go to the neutron-rich site.
GSI is in one of the pioneer labs in the world where you produced so many super heavy elements. Okay. Now, can you tell us this facility, how you will be able to go to which element or what said number you will be able to go with FAIR, this project?
Yeah, right now the heavy elements are produced up to Z equal 118. Now this is all done with stable ion beams. Now with a new facility where you have neutron-rich nuclei, you can expect really to come to the island where the heavy elements really live for a longer time. And this needs, of course, a lot of preparation. So the beams have to be slowed down again, and then you can perform fusion reactions, and then you can continue this research which has been used for quite some time at GSI.
Okay. So there was theoretical predictions is Z is equal to 126. Even Indian theoreticians has come up with some suggestions for which beam, which target projectile you have to use for. So do you think that such experiments are in the pipeline, or?
Yes, I'm pretty sure. You see, in the past one has used cold fusion where the nucleus is not so highly excited. Now in the meantime, people, especially in Dubna, they're using hot fusion, but as I mentioned before, only stable beams were used. Okay. And one of the leading laboratories using now radioactive beams, this will be FAIR, and I'm really looking forward to the young scientists coming to FAIR and to perform these kind of measurements.
Okay. So as part of the collaboration, as I understand, FAIR India collaboration is making so many instrumentation for FAIR, and you are developing new detectors. It includes silicon as well as ionization chambers,
yes,
and multi-wire proportional counters, as I understand. Like, is it right?
Yeah.
Yeah. So can you tell us?
So we are using now semiconductors, as you mentioned, silicon and germanium detectors, but we are using position-sensitive detectors of this kind, and this requires digital electronics, and this will be developed here as well as in Germany, and then we can really measure gamma rays with an accuracy of 1 millimeter. So if you hide, for example, radioactivity somewhere in this room, we can detect this without, let's say, walking around, just with one detector, which has a size of 8 centimeters times 8 centimeters from this position, and we will find this radioactivity here in the room. And we are using it for, of course, not, let's say, for searching radioactivity in the room, but we are using it for Doppler shift correction, because the ions which we are investigating, they have a velocity of 50% of the velocity of light. So all the light is shifted like, let's say, if you would be staying in a station, in a train station, and the train would approach you, then the tone of the train would be high, and if the train departs the railway station, then the tone would be very low. And in order to get the correct tone of the train, you have to perform this correction. And this we have to do in order to get the information from the nucleus. So we really appreciate this collaboration because it's really a strong collaboration, and it is a collaboration from both sides. So the Indian institutions with a new instrumentation will also profit when they perform the experiments with stable beams.
Can we discuss about carbon beams which FAIR is supposed to produce?
Yes. Carbon beams are used for medical treatment, and you can use this beam in order to cure a cancer which you have in your brain. So these kind of cancers you cannot operate. So you cannot cut with a knife into your brain in order to remove the cancer. If you would do so, then you would suffer afterwards cancer. If you would do so, then you would suffer afterwards maybe from not seeing or not hearing, because you have cut into healthy tissue which just controls the visibility or, let's say, the audio. So you can concentrate this beam to the brain without any harm, and you control the beam also by, let's say, emitting light from the isotopes, and you can cure the patient. So you need approximately 20 treatments, and you need special magnets to control the beam, and then after the 20 treatments you are cured. And at GSI we have treated approximately 400 patients, and none of the patients first of all died, and after the treatment, approximately 4 weeks after the treatment, the cancer disappeared because the DNA was destroyed in these kind of cells. So it is a very powerful system which will now go to the hospitals, and the acceleration facility will be, let's say, made on a smaller scale, and then many people can profit from these kind of carbon beams.
Here, can you tell us more about the nuclear waste management you follow with this new project?
We have a group working at GSI using nuclear reactions in order to change the qualities of this highly radioactive material. So when you perform a nuclear reaction on a material which is highly radioactive, you can turn it into a different element, and then the radioactivity will be highly reduced, and in this way you can control the waste of a reactor. But this has now to be proven to be working also in large quantities. But at least we have shown that you can use these nuclear reactions which we are using, and this is projectile fragmentation. This is a reaction process which is usually not used at low energies, and if we are successful also for larger quantities, then, let's say, you're very happy about these investigations.
Thank you very much to be part of this interface. Thank you.
Hello and welcome to the session on free and compulsory education. Compulsory basic education, claims on status all over the world. Free and compulsory education for all children between the age 6 to 14, irrespective of their gender, region, religion, social and economic status in the society, etc., is a motto which all the countries in the world uphold in the current era. The characteristic aspect of this scheme is that all the expenditure incurred in educating a child should be borne by the ruling government. Nothing should prevent a child from acquiring basic education, and if such an instance arises, the sole responsibility will be fixed on the government. Making it short, the intention of this scheme is to make education available, accessible and acceptable to each and every child. During 1990s, due to deficit budgets and debt pressures, the idea of free and compulsory education, even though born, laid idle, especially in developing countries. The main objective of international human rights is to alter the viewpoints of political society towards the marginalized sections who have only least access to the decision-making level. The majority of these sections can be considered as children. Children at an age of 6 should be at the primary school, but in many cases are not, as an inevitable duty of the government. The main problem in implementing free education revolves around funding. Only a few countries in the world have attained this successful funding towards education. For example, 1947 Constitution of Taiwan distributed its total fund for development of primary education as follows: the central government not less than 15%, state government not less than 25%, and the municipalities 35% of their budget. The oldest treaty in this subject is the bill passed in 1962, UNESCO Convention Against Discrimination in Education, which guaranteed free and compulsory education. Actually, a division of education into primary and secondary was challenged by the UNESCO. It specified that education should be a continuous process. Followed by this, other countries like America, Africa, etc. issued treaties which laid the framework of awareness about the importance of basic education free of cost. The prime point stressed in all these treaties is that the education of the children is not the duty of the parents. The government should sort out all the problems coming in the way for giving free elementary level education to the children of a country. The authority to implement this is decentralized conveniently so that right from the municipality level the program starts. Here, both the ability and willingness of individual government plays the most important role. This point can be easily understood when the situation in countries like Afghanistan, Angola, Congo, etc. are studied. Here, warfare impedes the implementation of any basic law for the protection of human rights. The ruling governments become helpless in performing anything effectively. It's notable that such countries are not even counted in the surveys conducted from time to time on subjects like development of education. Anyhow, regional experiences from Europe, America and Africa recently have undoubtedly contributed to the internalization of enforcement of human rights. Chile stands in the first place in the list by giving free education up to an age of 21. Countries in Western Europe, for example, Belgium, Germany and Netherlands, are placed on the top for achieving and extending compulsory education beyond 10 years. Placed in the lowest level are countries like Bangladesh, Laos, Nepal, etc., owing to the financial constraints. Free and compulsory education in India. An Act for Ensuring Free and Compulsory Education, RTE Act, was enforced by Article 21A of Indian Constitution in April 2010. The amendment was passed in April 2009 itself. Every child of the age of 6 to 14, including a child having different levels of disabilities referred to in the Act of Equal Opportunities Protection of Rights for Full Participation, shall have the right to free and compulsory education in a neighborhood school till the completion of her elementary education, says the article. It mainly aims the unreached and excluded children. This article explicitly specifies that any cost that prevents a child from attaining school education will be borne by the government. Important provisions in the Act are: no school can deny the admission of children owing to any reasons. Nothing in the form of fee, capitation fee should be levied from the child. If a child above the age of 6 is not admitted to any educational institutions, or after admitting could not continue the studies due to any reason, should be allowed to join in as class appropriate to his or her age. No school can expel a child till she finishes education till 8th grade. For carrying out the orders contained in the Act, the local authority should establish, if not existing, educational institutions to meet with the requirement. The central and state governments shall have the responsibility for raising funds for the smooth forward growth of this program. The Act also contains provisions for the well-being of disadvantaged children like child laborers, migrant children, and children with special needs, those disadvantaged owing to social, cultural, economic, geographic, gender, or any of such reasons. With the implementation of this, the common issue of out-of-school dropouts also can be handled to a certain extent, since provision is given for such cases also. The quality of education and teaching by well-trained teachers also are expected to be ensured. The necessity of appointing appropriate number of teachers is stressed. The qualification of teachers can be decided by the state governments. The instructions from the Union Government insist that local education authority should be formed in order to take care of the admission and further procedures in each area. It also states that teachers can avail 5 years' time to achieve the prescribed qualifications. If the region is hilly or having geographical peculiarities which may become a hindrance to commutation of children, suitable transportation should be arranged by the local authorities. In areas prone for landslide, etc., the bill makes it very clear that boarding facility is to be provided. The textbooks, uniforms, notebooks are to be made available to the children free of cost. All the schools in a particular area should accommodate the children without insisting any records or any fee. The aided schools run by private managements should leave at least 25% of their seats for accommodating children in pursuance of this Act. The unaided schools and special schools also should leave 25% of their total strength to be filled as per this Act. The central government and state government will reimburse the expenditure incurred for the education of these children for these type schools, provided no other financial assistance is being supplied. The funds are to be raised by the central and state governments by imposing and enforcing taxation on their wealthy population. It is a fact that many private schools are reluctant to admit children from economically weaker sections. The Act stipulates disciplinary proceedings, including cancellation of recognition against the managements denying admissions in their schools. Discussions are still in progress to settle this issue amicably. The Act also prohibits any kind of physical or mental harassment against children. Conducting any private tuitions and levying fee for that also is prohibited. Any kinds of discrimination to children in the classroom, playground, dining room, etc. are to be strictly avoided through the careful inspection of local authorities. A school management committee consisting of members of management, teachers, parents and members of local education authority should be formed for observing the progress of implementation of Act. The guidelines for the specified curriculum have been issued in a separate chapter of the Act. It is designed in such a way to concentrate on the altogether development of personality of children. The teaching is child-centered, and a medium of instruction will be mother tongue to the maximum possible extent. The curriculum emphasizes that the child should be free from any sort of fear, trauma and anxiety. He or she has the liberty to express feelings freely. No board examination should be conducted till the end of the elementary education. A certificate will be awarded at the end of the period of education. Almost all the states have started implementation of the Act, even though not in full swing. Andhra Pradesh backs the first place by posting teachers for every 30 students, totally 26,000 teachers, for implementing the Act. Tamil Nadu government also has given instructions to local educational authorities for expediting the steps for fulfilling the norms. Kerala state, which is far ahead in education, at par with any other states in India, has already attained universalization of elementary education. The Karnataka state government has taken strict disciplinary actions against some private school managements denied admission to local children in accordance with the Act. The Punjab government has already declared free education till 10th standard to the girl children, and this can be considered as a first step towards implementing RTE Act. States like Bihar, UP, etc. have not shown much progress, even though efforts are being put. Anyway, with wholehearted efforts of all state governments and union government, the idea to give free and compulsory education to all children in India would hopefully be materialized in near future. Advantages of free and compulsory education. The main advantages can be listed as follows. Education gives awareness of the basic rights of a person. Exploitation among the people in different levels of society can be reduced. Inequalities in standards of life can be minimized. The economic growth of the nation can be raised. Helps the country to get closer to the Millennium Development Goal and education for all. The reason for exploitation of the people in rural working class is mainly their inability to get acquainted with outer world. Education makes them aware of the surroundings and about their own rights. This is how getting education itself becomes human right of each and every child. It is practically impossible to educate everybody, including adults, in a society. The possibility is to bring the children into correct path so that coming generation will be gaining the benefit, thereby ensuring a brighter tomorrow. When money is demanded for basic education, let the name be anything: monthly fee, tuition fee, development fee, admission fee, etc. The children whose parents are not able to pay are deprived of the chances of getting educated. The nation might have lost already many outstanding intellectuals in various fields in this way. The only solution for this problem is to make education compulsory by strict rules. In this context, the assertion of the Universal Declaration of Human Rights that all the individuals have duties towards the society is to be remembered. It failed very pitiably to implement. Once the scheme is getting implemented, overcoming the controversies, it will doubtlessly work wonders. In the present society, it cannot be denied that the so-called weaker section exists. By making education among the children of this section compulsory, they will become aware about the rights they have in the society. At the same time, they will remember their commitments towards the upliftment of the nation too. The boldness and confidence to question social injustices will be acquired through education. Moreover, when primary and secondary level education is over, that may persuade children to lengthen education further. By the time they are attaining the age to get employed, they will be able to reflect their skill sharpened with education. Education structured in this manner will help children to learn a trade, develop a skill or competence, thereby promising a better life. Millennium Development Goal is a UN system's work which aims to eradicate poverty from the world. All the nations are given call to join hands for the fulfillment of this dream. By making education universal, this goal can be achieved easily. Factors impeding the implementation of Act. The main factors which become obstacles for implementation of the Act are: A. The existence of two types of schools, owned by government and run by private managements. B. The increased rate of child labor both in rural and urban areas. C. The attitude of parents towards implementation of free education. D. The wrong interpretations of government orders and procedural delay in implementation. E. Lack or insufficiency of basic amenities. Some private school managements are not ready to accept the procedure of admission to basic school as stipulated in the Act. Their usual way for admitting a child involves oral test, interview, etc. to make sure about the intelligence level of the child. Selecting good students and harvesting 100% success is the general practice followed. Such incidents of denial of admission under the 25% quota were reported in many states. Even if children are getting admitted out of the fear of disciplinary proceedings that may follow, the discrimination in dealing with such students will persist. Eventually, this can lead to the utter failure of the program. The tendency to make children engaged in employments is observed in an increased level both in rural and urban areas. When the reason for this in a family background may be poverty, in a workplace it becomes the benefit for the employer. In some instances, children have become victims for the various types of abuses by antisocials in such workplaces. The wages for a child employee is much less and the chance of protest will be very less. In a sum, child labor problem, which is much deep-rooted in the society, cannot be solved easily. The Act mentions the starting age as 6 years. Children in many cases are getting engaged in some workplaces well before attaining this age. So our primary free education also is equally important, which is not specified in his Act. This also can make hurdles in implementation of the Act. The parents whose duty it is to ensure that their children are availing this facility sometimes appear to be suspicious in many aspects. Among the lower middle class families, parents prefer to join their children in schools run by private managements which are reputed for their performance. As far as the families coming in the lowest level of social and economic structure, the very idea of sending their children to school itself does not have meaning. This works as a main reason leading to increased rate of child labor. All these factors make the implementation of Education Act tedious. Mere introduction of an act will not serve the purpose. Efficient enforcement in practical level is important. The protection of rights and enforcement of rules cannot work without corresponding government obligations. The union government clearly specifies that local authorities should establish the schools, inspect the procedures, and make sure that everything goes smooth. But in case any complaint or doubt arises, nowhere it has been mentioned where it should get redressed or resolved. If the same local committee has to attend to the complaints also, that will lead to further complications. Specified posts should be prescribed for redressal of complaints and for clearing the doubts. Another common factor is the lack of good, safe building and basic amenities such as water, toilets, playground, library, etc. Along with this, insufficient number of teachers also is a commonly heard complaint. Without such basic infrastructure, the implementation of the Act will not become fruitful. The filling of gap between normative and empirical structure in education field has to progress much to achieve the goal. Let me summarize the session. In this unit, the implementation of free and compulsory education in our nation and along the whole world is discussed briefly. Free and compulsory education in primary and secondary level will be a remarkable step in minimizing the social inequalities. The curriculum being set up for this is different from the monotonous, dry one where the young minds are in the grip of tension and unhealthy competition. Of course, there are hurdles in materializing the program, but a governance which is really committed towards the benefit of common men can overcome any challenges. Hope that you can try to answer the questions given here. 1. What is the status of free and compulsory education in the world? 2. When was Act regarding free and compulsory education enforced in India? 3. What are the instructions of the Union government for successful implementation of free and compulsory education in India? 4. What are the important plus points of effecting free and compulsory education? 5. What are the main impediments in implementing free and compulsory education in India? Hope that you can refer the books given here. Right to Education Primers by Katerina Tomaszewski, printed at Novum Grafiska, Gothenburg, 2001. 2. Committee Report on Education Bill 2005 by Rath A.K., published in 2008. Hope you have enjoyed the session. We can meet again with another topic. Till then, take care.
Hello and welcome to the session Technological Development and its Impact on Education. Module 1 Overview. Technology is bound to rule our present and our future. Technology has influenced our life a lot. In fact, technology influences how we work, how we play, and how we live our lives. Technology is an increasingly influential factor in education. Computers, mobiles, and the internet technology have revolutionized the field of education of today. This has made the education managements to rethink and redesign school curriculums since their goals have shifted its focus. This is a fact that we will have to face and understand. Educational technology is the application of modern skills and techniques to the requirements of education and training. Technology in education is commonly defined as a technical device or tool used to enhance instruction. This can include audio, visual, and digital media. This is not just limited to computers, computer peripherals, broadcasting technologies, and related software. The combination of education and technology has been considered as the main key to human progress. Education feeds technology, which in turn forms the basis for education. The rapid emergence of new technologies and its use in the field of education brings certain worries to mind. Some consider the use of technology in education as negative, while some talk about its positive side. According to supporters of educational technology, instructional technology empowers students by improving skills and concepts through multiple representations and enhanced visualization. Its benefits include increased accuracy and speed in data collection and graphing, real-time visualization, the ability to collect and analyze large volumes of data, and collaboration of data collection and interpretation, and more varied presentation of results. According to them, technology provides teachers with the instructional technology tools they have need to operate more efficiently and to be more responsive to the individual needs of their students. Selecting appropriate technology tools give teachers an opportunity to build students' conceptual knowledge and connect their learning to problems found in the world. Technology also engages students in higher order thinking, building strong problem-solving skills and developing deep understanding of concepts and procedures when used appropriately. Technology makes subjects accessible to all students, including those with special needs. Options for assisting students to maximize their strengths and progress in a standard-based curriculum are expanded through the use of technology-based support and interventions. Benefits of the use of these technology tools include increased accuracy and speed in data collection and graphing, real-time visualization, interactive modeling of invisible science processes and structures, the ability to collect and analyze large volumes of data, collaboration for data collection and interpretation, and more varied presentation of results. Rapid developments in the design and uses of technology, particularly in electronic tools, will change how students learn. While education in the past has been centered on teaching and learning, information technology has affected changes to the aims of education. Therefore, now education is increasingly perceived as the process of creating, preserving, integrating, transmitting, and applying knowledge. The people who are against technology use in education castigate it as a movement aimed to replacing the traditional teacher from the educational scene by using modern machines and gadgets. Not only this, but lack of proper training of technological devices limited access to sufficient quantities of technology, and the extra time required for many implementations of technology are just a few of the reasons why they are against the use of technology in the field of teaching and learning. They say that technology is not the end goal of education. Rather, it is a means by which it can be accomplished. If there is a lack of good grasp of technology among the teachers, then technology will be seen as a hindrance and not a benefit to the goals of teaching. What the world needs today is not talent in producing new technologies, but talent in understanding the impact of technology on the society and individuals. Education programs needs to be reworked to reflect the indigenous cultures and promote human values, while at the same time producing the talent for controlled technological advancement. Module 2, History of Education Technology. For the past 20 years, technology has revolutionized the efficiency of information gathering and management. Educational technology, in a way, could be traced back to the emergence of very early tools. The most known example will be cave paintings. The use of education technology starts with education films during 20th century. Large-scale use of technology for education was done during World War II. The soldiers were taught through training films and other mediated materials. Now technology has developed a lot. Today it is presentation-based technology where people can learn through oral and visual reception. This exists in many forms like use of computers, laptops, smartphones, whiteboards, projectors, etc. In 1983, computers were used primarily for three tasks. First, to teach students about computers, that is, computer literacy classes. And second, to teach programming. And finally, digitized communication and networking in education started in the mid-80s and become popular by the mid-90s, in particular through the World Wide Web, email and forums. The end of 20th century produced a variety of schools that can be put under the umbrella of the label computer-based learning. Technology used in classrooms. Educational technology is a broad term that may refer to many different kinds of technology that might be discovered in the classroom. Many teachers see that the term education technology means just using computers, films, television and other electronics to enhance student learning. But it is not so. Use of technology in a classroom means the use of full array of instruments accessible to improve a student's knowledge of the subject matter in front of them. The various tools of knowing technology could also refer to paper, pencils, blackboards, chalk, whiteboards, dry erase markers, picture projectors of any sort, tape recorders, digital recorders, calculators, laptop computers, audio recordings, DVD cameras, and interactive electronic whiteboards and more. The computer, along with the internet, has influenced nearly every part of our culture. Hence, computers inside the classroom are essential to prepare children to operate in today's world. There are various types of technologies currently used in traditional classrooms. Among these are computer in the classroom. With a computer in the classroom, teachers are able to demonstrate a new lesson, present new material, illustrate how to use new programs and show new websites. Students get more information in the class time from internet-based training. The computer can provide instant comments to clarify incorrect answers on quizzes, and it is infinitely patient and non-judgmental, which provides students a more optimistic mindset. Internet in computers helps in designing websites. Once a web page is designed, teachers can post homework, assignments, student work, famous quotes, etc. Most schools provide teacher web pages that can easily be viewed through the school district's website. Use of networks. Computer networking is increasingly being used in classrooms across the world. Networks are systems that connect two or more computers to each other. These computers can be at distant sites, allowing students or teachers to communicate with peers or with each other district-wide, state-wide, nationally, or even internationally. These networks allow computers to send and receive information to and from other geographic sites. Benefits of networks include collaborative learning and greater exposure to national or global perspectives. Interactive whiteboards. An interactive whiteboard provides touch control of computer applications. These enhance the experience in the classroom by showing anything that can be on a computer screen. This process of learning is one kind of visual learning. It is interactive, so the students can draw, write, or manipulate images on the interactive whiteboard. Video discs and CD-ROMs. Video disc technology can be used in either a tutorial or an exploratory fashion. When used alone, a video disc player enables the user to access and sequence visual images. When used in combination with appropriate hardware and software, video disc technology may be used as an individualized interactive learning tool, integrating visual and auditory information with electronic text. In many classrooms, video discs are being used for tutorial instruction by either supplementing CDs with textbooks or giving it separately. Using video disc images, teachers can demonstrate science information to their students very easily. Digital games. The field of educational games and serious games has been growing significantly over the last few years. The digital games are being provided as a tools for the classroom and have a lot of positive feedback, including higher motivation for students. Mobile devices. Mobile devices such as clickers or smartphones can be used in the classrooms. A smartphone is a mobile phone that offers more advanced computing ability and connectivity than a contemporary phone. A smartphone is a device that lets the user make telephone calls. It also allows the user to run and multitask applications like send or receive email, edit office documents. Clicker can be used to play games, take quizzes or tests, and to answer questions. Each student is assigned a clicker that is registered to them. The computer records all of its activity. The teacher can set up a series of questions on the computer and they can show the questions on the board. The computer will later tell the teacher which questions the student got wrong and what they put as their answer. CPS clickers allow teachers to track performance and academic growth. Wireless classroom microphones. For a too big classroom with hundreds of students, the microphones might help. With the help of microphones, students will be able to hear their teachers more clearly. Children learn better when they hear the teacher clearly. The benefit for teachers is that they no longer lose their voices at the end of the day. Class blogs and wikis. Blogs allow for students to maintain a running dialogue such as a journal, thoughts, ideas, and assignments that also provide for student comment and reflection. Wikis are more group focused to allow multiple members of the group to edit a single document and create a truly collaborative and carefully edited finished product. Podcasts. Podcasting is a new invention that is used in classrooms today. Podcasts are simply audio recordings stored as MP3 files or in another file format. The creator syndicates the recording via the internet and the listener plays it using a digital music player on a computer or a mobile device such as an iPod or a Zune. It allows anybody to publish files to the internet where individuals can subscribe and receive new files from people by a subscription. This is a technology that only requires a computer, microphone and internet connection. Podcasting has a capacity of advancing a student's education beyond the classroom. The students listen to the podcasts of the other students as well as their own, which improves their quality. This can be a great tool for learning and developing literacy inside and outside the classroom. Podcasting can help sharpen a student's vocabulary, writing, editing, public speaking and presentation skills. Students will also learn skills that will be valuable in the working world, such as communication, time management and problem solving. Satellite technologies. Distance learning programs are currently supported in nearly every state. Many of these programs focus on using satellite technologies to instruct children in isolated communities. Two-way audio and video. Distance learning is made possible when audio and visual signals can travel in both directions. Systems that provide both visual and auditory communication allow the maximum amount of interactivity between teachers and students. Audio systems provide monitors, cameras and microphones at the teachers and multiple students' sites. The teacher can see and hear the students. The students can see and hear the teacher also. Module 3. Impact of technology on education. Advances in technology have dramatic effect in the way classes are conducted over these years. The impact of technology on education has made the classroom become more dynamic, information become more accessible through a more diverse types of media, and the amount of information one could find is also seemingly immense. One of the most significant shifts in the way that technology is being used in education today is toward greater use of computers and other devices as tools in the learning processes rather than as instructional delivery devices. The impact of technology is thus very much evident in the educational setup in the sense computers has become the new classroom now. Traditional chalkboard setting has now evolved into digital projectors, interactive board. Books that have once burdened us for their volume and weight can now be digitally squeezed into a handy storage device. The physical library has now taken the place of e-book facility. Traditional teachers have become virtual instructors now. What was once an impossible task of teaching a person in a distant land without actually going there become possible. Big thanks should be given to the advent of computer and the internet. Finding and retrieving of information related to the subjects learned become easier than ever. The time in retrieving the information has also become insignificant because what will take you hours or even days to find decades ago could now be found in a click of a button. Rapid developments in the design and uses of technology, particularly in electronic tools, have changed how students learn. For example, graphic calculators and computer-based tools provide powerful mechanisms for communicating, applying and learning mathematics in the workplace, in everyday tasks and in school mathematics. Technology such as calculators and computers help students learn mathematics and support effective mathematics teaching. Rather than replacing the learning of basic concepts and skills, technology helps to connect skills and procedures to deeper mathematical understanding. For example, geometry software allows experimentation with families of geometric objects, and graphic utilities facilitate learning about the characteristics of classes of functions. These exploratory applications can support the kind of student learning that is the goal of education reform. Technology tools are designed to facilitate educational and work-related tasks. They are flexible, lending themselves to a wide variety of activities across the grade levels and throughout the curriculum. From an education reform perspective, this flexibility is both strength and a weakness. The question is whether technology tools are applied in ways that promote traditional instruction or education reform is dependent on the perspective, skills and practices of the classroom teacher. There are, however, significant practical limitations to many of the technology used in the field of education. Module 4. Challenges of using technology in education. Challenges for teachers using technology. When teachers use technology as a critical part of learning teaching process, they face a set of challenges, including learning how to use a variety of technology applications. Teachers can draw technology applications to simulate real-world environments and create actual environments for experimentation. But to do so, the teacher ought to be well studied of how to use the technology well so that students can solve their problems. They should learn how to operate hardware and software. Each new application brings new benefits and new problems to be solved. A teacher has to find out about the potential power each technology application has with respect to inquiry-based teaching and learning. Using, adapting and designing technology-enhanced curricula to meet students' needs. Finding quality materials to support classroom objectives after such changes is often difficult even after they exist in sufficient quantity, and teachers must design these resources on their own. When teachers integrate technology applications into the curriculum, they knowingly or unknowingly are curriculum developers. When there is use of any kind of technology application, teachers will have to engage in rethinking, reshifting and reshaping the curriculum. Taking on new roles. The nature of the teacher-student relationships is altered as both become co-learners. Knowledge is constructed in collaboration rather than transmitted from teacher to student. Responding to individual students. Within the classroom, close monitoring of students' learning can enable all students to benefit from reform-oriented learning activities. Many students need special support to manage the social and intellectual challenges of posing and exploring their own when they use new technology devices in class. The students try to get help with their individual learning needs, which become difficult for the teachers. There are also other issues which need to be dealt with while using technology. The first is that limited access for technology exploration because of the high cost of technology and the fear of damages. The inconvenience of resources placement is another. For example, having to transport a classroom to a computer lab instead of having in-classroom computer access by means of technology such as laptop cards is very difficult. Technology implementation can also be time consuming. There may be an initial setup or training time cost inherent in the use of certain technologies. Even with the advantages that technology provides us, it is important to see that technology doesn't remove the need for books. Now you can try to answer a few questions given here. What is the role of technology in the field of education? Describe in detail the various technology instruments used in a classroom. What are clickers or smartphones? How is network used in classrooms? What are the challenges faced by the students and teachers in using technology? You can read the books given here for reference. Alan Janosky, Educational Technology, The Development of a Concept, published by ISBEN. Hope that this session was beneficial to you. We will meet again with a new topic soon. Thank you.